morning. Welcome to GitHub Universe. Today, we are going to walk you through how we use GitHub at GitHub, and along the way, show you some of the really cool new features we've been building. Let's check it out. I start my morning with the GitHub mobile app. I check out my notifications, and I catch up with my favorite communities. GitHub Discussions makes this so easy. We announced it a few months ago as a great place for Q&A and open-ended conversations, and today we're announcing that every open source community can try GitHub Discussions with our new public beta. Just head to your repo settings and turn it on right now. We've learned a ton from the communities that have already been using Discussions, and we've added some great new features like customizable categories and native support in our mobile apps. It's awesome. Oh, this is a really interesting idea that came from the community. I actually think we should work on this. So I am just gonna @mention Ryan to see if he can figure it out.
Hey Leo, check this out. Nat just pinged us. Huh, that is a great idea. Let's open an issue and get started. Discussions is where your community has open conversations or asks questions or just hangs out. The issues is where you go to plan and track the work that has to get done. Maintainers always tell us that if you're gonna have a healthy project, it's crucial to separate the work that's happening on that project from your community's conversations. That's why we created GitHub Discussions and GitHub Issues. Issues has all the project management tools like boards, labels, assignees, and anything else you need to share, plan, and prioritize across GitHub. All right, I need to loop in Neha. She is the animation expert on the team. Let's mention her and see if she can help. Hope she's not too busy. All right, Leo, gotta run. Text me if you need anything.
Ryan. All right, I think Ryan wants some help coding up animation. Let's take a look at the issue. With the new GitHub CLI, not only can I read issues from the command line, but I can also clone repos and work with pull requests and more. It looks like we need to add P5.js to animate some of our SVG-based octocats, but it isn't in our dependencies yet. Let's add it real quick. We're just getting started, but I like to open a pull request on my first commit and mark it as draft so that the squad knows that it's time to get information.
Nice job!
Looking at the PR, we can see that there's some new dependencies to power these animations. We should give them a once-over. That's super easy with our upcoming dependency review tool that's built into pull requests. It automatically surfaces security vulnerabilities and helpful information about the added dependencies when you preview the package.json. I see we're pulling in a couple of libraries that have vulnerabilities, so I'll need to update these to the patched versions before we merge this. P5.js is a key dependency for animating these octocats, and we want it to be something we can depend on for years to come. So why don't we invest in it, yeah? Let's look at the repo. Yes, we can fund them with GitHub sponsors. I'm busy coding though, so I'm gonna delegate this up. Let's ask Nat to help out with this.
And now, a word about GitHub sponsors.
With GitHub sponsors, you can fund the open source projects you depend on and the developers you admire. GitHub sponsors has already been a game changer for developers, including some who've been able to quit their jobs and go full-time as professional open source developers. They don't work for any single company, they work for the internet. Now, We want open source to thrive for years to come, and given that every company in the world now depends on open source, we know our community can do more. So starting today, companies can sponsor projects and developers through their existing billing relationship with GitHub. So let's sponsor this project. Leading companies from around the world have already joined us in supporting open source maintainers through GitHub sponsors. All right, I'll let Neha know we've done it. And now it's time for lunch.
Now that we're sponsoring P5.js, I'm even more excited to use it in our project, which means that this PR is ready to go. Let's mark it as ready for review to kick off the code review process. Since we have a code owners file in our repo, GitHub automatically assigns and notifies the team members to review the changes. The team can leave comments and even suggest changes for me. And now for the coolest part. Manually merging a pull request is nice and all, but how about we let the robots do the work here? Check out auto merge. Now, when your branch protection rules are met, your change is approved, and your checks are green, GitHub can automatically merge your pull request for you. Just tell GitHub how you want to merge with a commit, rebase, or squash, and we'll make it happen. I just need to rely on one more human, and that human is Ryan. Where is Ryan anyway?
Whoa, it looks like Neha cranked this out already. Let's check out the pull request to give it an approval so we can ship it. With GitHub Mobile, not only do I get push notifications for things like comments, but I can keep working on any of my repositories no matter where I am. Let's jump to Neha's pull request and take a look. With UI changes like this, sometimes it's hard to know if everything's working just by looking at the diff. Sometimes I actually need to run the app to see the changes. This calls for a code space. GitHub Codespaces gives me a complete dev environment right in my browser, even on an iPad. It's like an infinite dev box configured in code, just how you need it. And since Codespaces is built on top of Visual Studio Code, it gives us a fully featured editor right in my browser, complete with built-in terminal access and shell access. While my application is running on a container at GitHub, I can securely connect to it right from my browser. Whoa, lowercase h, that's a bug. Let's fix it real quick. Now I can just commit and push this change right from my code space.
Yeah, I'm gonna snooze that notification. Brian's got my back because he's doing deploys today.
Notification. Yo, I love getting a good notification. When we're building software, we turn to GitHub Actions. As you can see, we already have actions up and running in our repo for pull requests and CodeQL automatically looking for security vulnerabilities. With our tests all green, I think it's time to kick off this deployment. GitHub Actions is so much more than CI. It can react to any GitHub event to manually trigger a deployment. Let's start by publishing a new release. As soon as our release is published, our deploy workflow is automatically triggered. So let's take a closer look at these two new legit features, starting with our new Workflow Actions Visualizer. This new UI is looking fresh. You can see exactly what's happening in your workflow, how steps and jobs relate, and even what state they're in. For example, here we're running the final minification and bundling steps in parallel while regenerating our project's documentation before we deploy out the staging. Now we're ready to talk about the final workflow step. Also new to GitHub Actions is the ability to require manual approvals for action workflows. You can set protection rules and give each environment dedicated secrets. That means you can make shipping painless while also making sure authorized team members can deploy to production. Staging is looking legit and everything's looking hella green. So I'm gonna approve this deployment to go to our production environment. And with that, our deployment is live. GitHub Actions is becoming more powerful by the minute. And with over 6,000 open source actions in the GitHub Marketplace, you can build and automate just about anything. Real talk, you could even order a pizza. Yo, this is legit. Let's tell the community this is crispy.
Tens of millions of developers use GitHub, but so do hundreds of thousands of companies, including some of the biggest in the world. For those users, we've been hard at work adding all the new features you saw today to GitHub Enterprise Server, so you get all the power of the best teams in the world running on your company's network. That includes GitHub Actions, packages, code scanning, and support for the native GitHub mobile apps. All of this is available in a major new release we call GitHub Enterprise Server 3.0. This is the biggest release we've done of GitHub Enterprise Server in years. Okay, that was an awesome day. The team went from an idea that came from our community all the way to production using discussions, issues, the new CLI, our native mobile apps, code spaces, pull requests, code review, branch protection, continuous deployment, advanced security scanning tools. You saw it all. At GitHub, the thing we care about the most in the world is developer experience. So whether you're an open source developer, you work at a company, or you're a student just getting started, our job is to make it easier for you to build amazing things. That's why we're here. So we hope you enjoy the conference, and we'll see you soon. What a day.
So bright.
Hey Nat, you're up late.
Hey Diana, sorry to bother you, but it is just so bright. Where are we with dark mode?
I've been trying to ping you in Slack. It's been ready for ages.
You're waiting on me? Oh man, it must have been the time zone. Sorry if I missed your message.
Yeah, because it's like 19 hours difference between San Francisco and Sydney. This has been ready for 6 months.
Oh, do you think you could resend the approval to me?
Yeah, let me quickly deploy it for you.
What was that?
Matt, are you okay?
Is it real? It's awesome.
Microbium is a fun and friendly sandbox for experimentation with simulation-based generative art. Designed for simplicity, you will only need to learn one brush tool to start making interesting art. In-depth style and motion can be achieved with the flexible rendering and simulating systems. To get started, download the built application or clone the GitHub repo and build from the source. Once the app is running, get acquainted with the UI control interface. This is where you manipulate the parameters that will control the brush tool, view and camera settings, simulation forces and constraint groups, line and fill style layers, generative geometry modifiers, and finally, post-processing effects. The default scene includes a basic setup of a few active physics forces, physics constraint types, and line style layers. Each new drawn line will be linked to the active physics constraint type and style layer. Updating the properties of a constraint group or style layer will update all linked lines. Properties can be updated in the control panel or bound to MIDI CC channels. When bound to a CC channel, each controller can also record inputs over time and play them back in a looping sequence. This integration allows live, complex modulation of many parameters. When navigating the editor viewport, hold Option and click and drag to pan the camera view. Draw strokes by clicking to precisely add each point individually, or click and drag to draw a fluid path. Each path can become interconnected to other paths by clicking on top of an existing point, creating a shared vertex. Closed paths are rendered with a 2D fill. The scene visualizer runs in two modes, editing and simulating. When running a simulation, new paths cannot be added, but cursor movement can be mapped to active forces to influence the simulation. When switching back into editing mode, all mutations to the geometry are preserved and new paths can be added. Geometry modifiers and post-processing effects are a big part of the rendering engine. Polar duplication, color correction filters, and blurred feedback are a few effects that can be tuned for each scene's look. Microbium was built using web technologies and packaged with Electron for distribution. It's comprised of two main pieces, the visualizer engine and the UI control interface. The controller UI is composed of modular components built with the Vue.js framework, and the visualizer is rendered with a custom engine using a WebGL backend. The main visualizer view is built with WebGL library Regal, which is described as a functional, data-driven abstraction layer on top of the native WebGL API. The library exposes two primary interfaces, commands and GPU resources. Command is a complete representation of the WebGL state required to perform some draw call. A resource is a handle to a GPU resident object like a texture, FBO, or buffer. This is really a useful library to get started with WebGL and shaders, as it greatly simplifies the complex state management needed to set up shader programs and resources, while still providing low-level access to all the features of the native WebGL API. As WebGL has poor native support for line rendering, the app uses a custom-built line rendering library. Each subsection of a line or curve is drawn as a screen-projected quad with projection computation running on the GPU in a vertex shader. Rendering lines this way enables smooth tapering of line weights, as well as use of fragment shader modulation and texture sampling to render complex stroke patterns and shapes. The fluid-like kinetic animation characteristics of scenes rendered in this app are driven by a custom lightweight physics engine. Each vertex in the vector network becomes a particle in the simulation, while each subsection of a line segment becomes a distant constraint. Global forces act on particles while constraints maintain local relationships. All particle vertices are stored in a single-typed array which is mutated by all active constraints and forces. This architecture is really fast and memory efficient even for large simulations. The system is based on the one used in the first Hitman game, known for its ragdoll character physics. Drawn vectors in a scene are created with a vector network architecture. Unlike most vector-based systems which compose individual isolated paths, all paths in this network can become connected and merged into any other path. This allows complex structures and shapes to be built up out of interconnected paths and lines. For each frame, the full state of the current scene and controller parameters is pushed through a set of Regal draw commands. This style of building commands in Regal was inspired by React and ensures that the rendered scene is always up to date with the current scene state. This style is much different from an object-oriented design such as Three.js, which manages discrete objects in a graph. For instance, to draw 8 radial iterations of a line, the draw command is run 8 times according to the underlying data. In contrast, Three.js would require managing the addition and removal of unique objects from the scene. Scene state is serialized in multiple steps. Repetitive keys are remapped to abbreviated names, typed arrays are converted to compact string representations, then everything is stringified to JSON and saved to disk as a gzip text file. This process is reversed for loading a scene and generally takes 1 to 2 milliseconds, allowing hot swapping scenes while a simulation is running. Microbium is an open source project hosted on GitHub under the Microbium organization. I hope you feel encouraged to check it out and tinker with the code or start a similar generative art project of your own.
Hi, I'm Sam Aaron, and I'm here to talk to you about how you might be able to use your coding skills or learn some coding skills to become expressive. What on earth do I mean by that? Well, typically you learn to program to build business apps or web apps or as a career, which is a great thing to do. And many of you out there may be already doing that, and that's brilliant. But there are many, many others who yet to really touch code, to become familiar with it, to understand what it is. And for them, particularly, I think we need to find ways to reach out to help them to understand what code is and what it can do. And I think building business apps is one thing, but I think that being expressive with it, using it to share your feelings and thoughts in new ways, I think actually is a really powerful and wonderful and yet to be really fully explored aspect of programming. And that's really what I've spent most of my life exploring myself. And all the tools I've built, all the things I've learnt, I've tried my best to compact together, to squish into a little small thing that I can give to you to play with. And that, the latest version of that is a tool called SonicPy. And this is an open source, fully free tool that lets you write text in the same way you might write in a Word document, but it has a special button which you can press, which then turns that text, that code, into music. And we're going to see how that can help you get started to program. But also, if you're a professional programmer, this is still a really interesting tool for you because it has concurrency, has event data stores, it can do distributed programming, it's deterministic, it's got all sorts of cool fancy features that let you really do some really explorational advanced things with your skills. And that's actually really what this is all about. It's about creating an equivalent of a guitar. And why would I talk about guitars? Well, think about a guitar. It's an object you can pick up that most people can pick up and most people can play and strum, hit all the strings. So starting the guitar is actually quite a simple and easy thing to do. But the reason why most people pick up a guitar probably isn't because it's a beautiful object made of wood and looks lovely and shiny and polished in the shop. It's probably because they've seen their favourite artist, Jimi Hendrix or Taylor Swift, perform. And they've seen this weird wooden medallion around their neck and they've said, what on earth is that wooden thing around their neck? I need one of those. And their friends have said, that's a guitar. And so that's why often they've picked up a guitar, because they've seen motivational and aspirational figures using that instrument to do amazing things. So I think that when we're thinking about creating experiences with code, we need to think about both of those things simultaneously. Firstly, making sure it's super simple to get started, and we'll see hopefully how that's the case with SonicPy. And then secondly, to make sure that if you practice and put in the effort and learn and study and work hard, then you can be rewarded with being able to do things that you could only dream about before. And I think that's true with the guitar, and it's also true with SonicPy. And I'll be showing you a little bit of that today in this workshop, but really this workshop is about getting started. But at the end of the conference, or towards the end of the conference, I'm going to deliver a performance, and that performance is going to be my demonstration to you of what you could do if you practiced. Now that performance is going to be pretty special. It's going to be the first time I'm ever going to live code a performance that also includes your work. So we're going to see at the end of this workshop a challenge to call to you to produce your own small little riff, audio riff, and I'll show you how to do that you can then use to obviously play yourself, but then you can send it to me, and there's going to be a link below in this description of this video of where to send that little snippet of text. It'll be like 8 lines of code. There's nothing complicated. And then I'll be able to collate and bring those together, and depending on, if I get a million of them, I'm not going to be able to use all of them, but I'm going to use as many as I can and integrate them with my performance and show your names and to work with your code as much as working with my own code to make it more of a collaborative performance. So that's going to be quite exciting. So today we're going to get to understand the beginning and how we can get started, and then the performance is going to really show you hopefully what you could achieve and give you hopefully that motivation to really to learn this thing and to become the DJ of the future, really. That's how I'm going to describe it. I mean like the DJ of the future, right? So here I am in performance mode, and I've got my code on the screen, and I've got my crazy visuals and stuff, so you can do this kind of thing. But what you're really seeing is this code here, and this is the SonicPy editor, and this text edit environment is just a text edit environment. I can type words, and those words have to mean something to the environment. So this crazy load of letters does obviously means nothing. So if I try and run that program, that doesn't work. So we obviously need to know the very basics of this system. And so the basic program you can write is the word play and choose a number like 70 and then hit the run button. And it creates a beep. So this is a complete, fully functioning, syntactically valid, semantically correct program. And this is a kind of program that many children all over the world who have used SonicPy to learn to start programming have all written. And this is lovely. I mean, it's a great way of just getting started where you have a very simple thing to write and you have immediate feedback. You're not looking through tools of logs or where things are. You're just hearing a beep. And you have control of that beep. I mean, you can play some options. I can play that beep louder or quieter. I can play it up too. I can choose how high or how low that beep is. And so I have the ability now to manipulate the pitch, the how high or how low that note is by changing this number. For those who are interested, the units of this is what we call MIDI notes. They kind of map on to notes in a piano. So each whole integer that goes up is the next note, including the black notes on a piano, or if you go on the fretboard of guitar, it's one rung up the fretboard. So we can see that. You can hear that. But this is interestingly, this exact note you're hearing now is determined and defined by Western standards. So we're hearing what Western orchestras might play for note 55. And that just happens to be a decision that has been agreed upon, and it only really holds in the Western traditions of music. And if we break out of those, we really start to explore all sorts of interesting ways of choosing how high or how low your note is. And so SonicPy, although it makes the Western tradition easy by using integers, it does give you access to playing fractions of notes. So you have essentially floating point access to the range of notes you can have. So you can play essentially any note you can perceive, you can play with the system by just choosing the right number. And you don't have to stick to whole numbers. You can stick to floating points if you want to break out of the Western traditions, which I think is pretty exciting. So far though, I've just shown you one line of code. What about 2 lines of code? Let's play note 70 and then play note 75. Now, the way to learn SonicPy is to write the code, not press the run button, just imagine what it sounds like. So I invite you at home to look at that code and to imagine what it might sound like. Note 70 and then note 75. Ooh, they played at the same time. Now, you might have expected it to play note 70 and then note 75, and actually in the early days of SonicPy, when I first created it, that's exactly what it did, but it did it so fast after one after another you couldn't hear it, just as the computer is crazy fast at interpreting the instructions. But actually in the more recent versions, this is actually played sample accurately at the same time, so really precisely at the same time, because timing and music are something which really work and are important and are necessary for each other. And so SonicPy has extremely good timing semantics. That's really one of its core skills. So if we want to make a melody, we break it out by adding a sleep command, and that then allows us to tell the computer to go to sleep between note 70 and note 75, and this way we can now make our melody of whichever notes we want. Let's go for 82. Lovely. Now, this might be fun. It is fun, I think it is anyway, and but it might be fun to you. But what I think is really interesting is that this is likely to be fun to many more people in your lives than talking about, I don't know, Nginx configuration, or enterprise Java service beans. Are they still a thing? No, probably not. What else might you talk about? JavaScript promises. I don't know. Whatever the latest technology, the latest whiz-bang thing is, the chances are most of the people in your lives who aren't programmers are going to struggle to follow along and be interested. Whereas if you talk about music, actually, I found it's much more easy to have that conversation and to keep them engaged. So I think this is more likely to interest a broader audience. And I think this is the goal of Sonic Pi. So Sonic Pi is meant to be two things. It was meant to be a musical instrument. I was talking about guitars, talking about the fact you can get started and how easy it is to get started with a guitar or a piano. Here, hopefully, you can see that this is also easy to get started with. We have access to pretty much any melody you've ever heard or will hear with two commands: which note to play and when to wait, how long to wait for the next note. But, and this is a crucial thing, this also gives you access to doing really sophisticated and really interesting detailed music. So we can take any of the synthesizers here and bring them all in and mix them together and all sorts of events and sounds and have a lot of fun. And we can have access to all of that here as well. And all you need to do for that is to start adding more code, essentially, to explain the different kinds of things you might want to do. So, what do I mean by that? Let's play note 70. A bit more code is the release command. Oh, get that correct. That's how long the note lasts for. Or I could attack. That fades it in. Or I could fade it in and have no release. Oh, suddenly cut off. Or I could change the synthesizer. Let's change it to Profit. That actually works much better at maybe... Some of you might want to know why I'm doing this subtraction here. Actually, you can obviously just throw some maths in there, but 12s in Western music is an octave. So 3 times 12 is 36. That's going down 3 octaves. Just saves me having to do that mental arithmetic in my head. So we have now ability to play these notes. Let's go for release 8. Let's make it louder. Let's make the cutoff 70. Here I'm able to mix kind of like drone music essentially by layering the sounds on top of each other. Probably for this kind of environment you want to be in sort of dark mode so that you're in some sort of like a nightclubby environment and you're playing these sounds. So what we've got here essentially is multi-threaded environment. So each time the code goes pink, it creates a new thread of execution and gives that thread the code that you can see on the screen to execute. And it runs through that code from the top to the bottom, and when it finishes, it automatically stops that thread, garbage collects it, tidies all the things, all the resources it's been allocated, and then frees it so you can have another thread. Of course, that means you can have the multiple of these threads running at the same time, which is why you're hearing the sounds layering on top of each other, which gives you really a lot of interesting potential for drone music. But it also has a really other important aspect as well, because in Sonic Pi, well, you've seen already that we can do play. We can play multiple notes. We can wait between the notes. We can change the length of notes. We can change the synthesizer. Yep. And so this gives you access to a huge amount of music possibilities already. You can essentially compose your own piece of music. You can change the sound as it's being played. You can change the length of the sound. You can change the qualities of the sound with this cutoff and other things. And each of these synthesizers has documentation describing all the different things it can do and all the options it supports in the documentation system already there. So you have a lot of fun and power there. But there's there's 2 more really actually quite exciting things to show you that really can get you started and advance pretty quickly. The second one is, well, obviously you can use control structures. That's not even a thing to explain. Look at this. 8 times. So I'm going to play that note, wait for a small amount of second. Here's an eighth of a second. So let's play it 75. Or I can do a scale, for example, E3 minor pentatonic. I can choose a random note. It's pretty cool. So this code here is pretty much the start of the challenge, which we'll get onto in 10 minutes or so. But so just to get it in your head, this is the kind of code I'm going to hopefully ask you to write. But listen to this. First of all, notice that it plays the same thing every time. So what we're hearing, even though we've got this word choose, which you think might be to do with randomization. Maybe I've got like a bag of letters, I'm playing Scrabble, and I'm pulling out random letters. If I pull out 8 letters, and then put them back in again and pull out a different 8, I'm going to get a different 8 letters. But yet with Sonic Pi, I always get the same ones. And that's because by design, Sonic Pi is what we call deterministic, which means that it always does the same things every time it runs. And that might sound limiting, like, oh, but I want my randomization to always be random. Surely that's the point of randomization. Well, actually, you want probably 2 things. You want it to feel random, so that you can try new things out. And we can get that feeling by changing what we call the random seed. So by default, the random seed is 0. What we heard before is the same. But actually, by putting some random number in here, we get it to make different choices. Or this number, or this number. Now, if we like that, we now have the ability to reproduce it. So the cool thing now is that if you were to take this code and copy and paste it, or just type it out again into your version of Sonic Pi that you've downloaded from the website, you will hear exactly the same notes played in exactly the same way. So that's the second benefit of a deterministic system, is it allows us to share the code and to know what the people who play that code are going to hear. That turns out to be really useful for collaborative jamming and for composing together with friends in a distributed fashion. Which means that code that you upload to GitHub and to a gist, say, that you copy and paste in Sonic Pi, you know you're going to hear what the person who created that intended you to hear. That's a critical thing. But then another thing to show you is the effects. I can use an effects block. Well, what do I mean by that? Well, here we have this do end, which describes the iteration. Where to start the iteration, this do. So I'm going to do something 8 times. And this is what I'm going to do. I'm going to do everything between the do and the end, which means all this code, any code that was written between these 2 words, do and end, will be repeated 8 times. We can have another do end block around that. You can see it's nesting it, and we can do something else with that code. We can use with effect. Let's choose reverb. Let's make sure that it sounds like it's in a big room. That's nice, isn't it? Or I could choose echo. I could choose crush or bit crusher. And there's a whole ton of these effects that I can play with. Flanger. Which can change the quality of the sound. So these are kind of like guitar effects pedals that you might buy from a shop. They're about, I don't know, $100 each. You buy 5 of them, chain them together, and then you plug your guitar ends, and you can twiddle the controls, and you can change the sounds. Well, in the same way with that, you can nest these effects inside Sonic Pi. So I can play it through Crush, and then through Flanger, and then I can play that through Reverb. And we could nest these things together. So this play sound goes through the crush, goes through the flanger, goes through the reverb, and then you hear it. And then so we're able to combine all these effects together. So this is a really cool technique for being able to change the quality of the sound in the same way a guitarist can change the quality of their guitar by using these effects pedals. So now we've learned how to play notes. We've learned how to play any note you can hear by using floating points. We can wait between notes. We can make any melody. We can change the sound of the sound by changing the synthesizer. And also we can change some of the options of the synthesizer, which are basically like these kind of knobs on this synthesizer here, but they're just words, key value pairs, an associative map, as it were, of control values which are passed to as a parameter, an optional parameter to the function play. We can then use things like control structures, like iteration, to do something 8 times or 7 times or 800 times, how many times you want to do it. Repeating this around here. And then we're using lexical closures or so-called effects blocks to then wrap around your sound code to change the sound. So this means that the play of the chip lead sound, which is playing here, is going to be crushed, flanged and reverbed. So you're going to get this new kind of sound. And you're obviously changing the order of those will change the sound, and removing them and adding them will change it around. So that's a lot of fun. And this is essentially what I'm hoping you might come up with the challenge, which we'll talk about in a moment. But before that, I'd like to show you one more thing, which I think is really quite fun. And that is being able to live code. So everything we've talked about so far is sort of a compositional mode, where we're writing a bunch of code, changing the sounds, changing the timing, pressing run, hearing the sounds. What actually is also fun to do is to make a loop. So let's play a sample. So we can also play pre-recorded sounds. So let's play this loop amen break. Play it quite loud. We can beat stretch that to match 2 beats. We can create a loop. We can seek for the 2 beats, and now we have an endlessly repeating drum break, which is pretty cool. So let's just park that for 1 second, and let's do it again, but with a different sample. Let's play the bass drum house sample, and let's seek for half a beat. Cool. Now I was amazed actually by the number of times I've seen people write this code. So let's for effect, let's do this. So now we have this code here. Again, as we saw before, the way to learn Sonic Pi is to read the code, imagine what it sounds like in your head, and then press the run button. So just spend a moment. You heard the kick drum, you heard the amen break spinning round. Let's hear what they sound together. Oh. Where's the amen break? Well, if you're a professional programmer, and this is an interview question, why can't you hear the amen break? I'm sure some of you are screaming out to me, it's because you've got a single threaded application and the loop is infinite and the program never exits a loop. Well, okay, what do you mean? So let's think about this. The code starts at the top of the program and works its way down. That's typically what happened in most traditional programming languages. So we get to this loop. Here's the first thing, really. These 2 lines here are blank. And this means loop forever. So we play our sample, our bass drum, we wait for half a second, and then we loop around. Play a sample, wait for half a second, then we loop around, and we loop around, and we loop around forever. And we never, ever, ever get down here. So that's a problem. So the solution to this is to use threads. Now they might be a nightmare concept that you sort of don't touch them, you get out your garlic and you hunt them away like vampires. But inside Sonic Pi, actually, threads are really nice and they're really friendly. And the way to use threads inside Sonic Pi is to use live loops. Let's call this kick, and let's call this drums. So you give them names, and then you run the code. And you can hear that. I mean, actually, that kick drum's not loud enough. Let's make it a bit louder. The sample, maybe let's make that half speed. Get rid of the sample, find the way. Let's change the cutoff of this drum. So, live loops have 2 cool properties. One is that they can play things at the same time, so this idea of concurrency. So this actually is completely natural in a band. Now you have a singer and a guitarist and a bass player. They will all play at the same time to make the band. But they do another thing actually, which is pretty critical, which is playing not just at the same time, but in time. So these 2 threads, the kick thread and the drums thread, are not just executing simultaneously, as you might imagine a traditional programming thread to do. They also play in time, which means that the kick drums kicks exactly the same time as the amen starts, and no matter how long they play, they don't drift out of time, they don't drift back in time and mess around. There's none of that. Everything's completely hard synced. I mean, I've spent a lot of time and effort actually behind the scenes making this work. A lot of my time has gone into making the timing system as precise and deterministic and accurate as I can. I'm still working on that as well. So we had the concurrency, but there was one other thing. We could change the code as it runs, and that's a critical thing. This is the sort of the opening gateway to what we call live coding, being able to play the code and modify it as it runs. And when you see me perform in my performance, you'll see me writing a bunch of these live loops. They're all doing a simple thing, but a few of them together combine to make something interesting and complicated. Just like if you took out a bassist of a band and just played them on her own, she's probably going to play quite a simple riff. And the guitarist, she's also going to probably play a simple riff, but put them together and it sounds much more interesting. And that's the same with live loops. Each one of them probably only does a simple thing, but combined together, you get really cool effects. So this really is the opening point to exploring more of what Sonic Pi can do. You can use it to get started. You can use it to get started with 6-year-old children, anyone who can essentially type and read with play and sleep. You can start advancing into different sounds, controlling those sounds, adding effects, using iteration, and then also starting to live code with live loops, which let you play multiple things at the same time. So one live loop doing the bass, one live loop doing the synth riffs, one live loop doing the drums, and then bring them all together and modify them as they're running to make that performance. And if you want to get more started, you want to learn more about this, you want to actually open up the tutorial. So you just click on the help system, and you can see here there's a full tutorial built in. This is also available on the website. If I go to the website, you can actually see that I can click on the tutorial section and I can work my way through the website as well. So you can read everything I've shown you and a lot more on the tutorial. But let's finish with a challenge. So I hope that you might be interested in getting started and also possibly contributing something into my performance, so I can bring in your code and use it to make your sounds come out of the speakers of my performance and integrate it with what I'm doing. And so for that, rather than just ask you to make anything and figure out a way to somehow stitch it together in a way that makes sense, I'm going to ask you to work with the E3 minor pentatonic scale. Now, if this doesn't mean anything to you, don't worry. This is kind of like a color palette. If you're designing a website, your designer might give you a bunch of colors and say, only use these colors, please. This particular red, this particular green, this particular yellow, or whatever the colors are. And as long as you stick to those color palette of colors, it's going to be fine. And this scale is essentially a color palette of notes. It's just a list, actually. I can print that on the right-hand side, and you can actually see here it's 52, 55, 57, 59, 62, and 64. They're your notes. So if we'll stick with those notes, and then we can do anything with them. So I'm going to spend the next 1 minute 30 giving you as many ideas as possible. And as long as you're working with these notes, it doesn't matter. Just throw it at me, and there's a link below to submit your code. A few lines of code. So a valid submission would be, let's give this a name, notes, and let's do 7.times do play notes dot choose sleep for 1 second end. There we go. There we are. That's a valid solution. So if this could be a solution, just take this code and submit it to the link below. But what I would recommend is to start with something like this and then just slowly tweak it. What happens if we make the release time short? Yeah, and add some reverb. Maybe change the room size to 1. Maybe use synth to be 303. Maybe cut off 70. Maybe a random cutoff between 70 and 130. Remember, all these things I'm showing you are in the tutorial if you want to learn more. Yeah, that's nice. Maybe choose a lower E. depending if you're making a bass line or a melody riff. Maybe even choose a different timing. Or randomize the timing. All these options are yours. I'm looking for a short piece of code that uses the E3 minor pentatonic scale, whatever synthesizers, whatever timings, whatever release times and cutoffs and all things you want to play with. Choose your own, play around with it, does not need to be complicated, and then submit it to the link below, and I'll bring them all together and bring them into my performance. Okay, so that's me done. Thank you so much for watching my workshop. I hope that this hopefully gets you started, really excited hopefully, to understand the true potential of code is not just for making business apps. It's also for humans expressing themselves in new ways. And music is a beautiful medium for that expression. And I really hope that some of you might start your adventure of exploring how you might express yourself with code and music using Sonic Pi today. And I really hope that one day in the future I can come and see some of you perform and come to your gigs and crazy dance like a mad person who dances to people who make music with their coding system. I'm sure that happens for everybody. Anyway, thank you so much for watching, and I hope for you to see you all around soon. Thank you. Bye.
Hi, nice to meet you. My name is Sabine Wieluch. I'm also known as BleepTrack, and I work a lot with generative and AI art. And I'm very happy that I was invited today to give you a super quick dive into generative art and how you can code your own generative art with Paper.js. So yeah, let's get started. And what is generative art? So the main goal is to make some sort of art in the end. This can be anything you can think of: images, videos, music, poems, whatever you like. Though in this workshop we will go with images, and to make this even more detailed we will create vector graphics, SVGs. And yeah, when we talk about generative art we always use some sort of rule set to make our art. This rule set in our case will be created by code, by an algorithm that we write, but this doesn't need to be the case all the time. Some people also work with dices, and they just use dices in the physical world to generate random numbers, and then put that in their rule set that they have in their mind, and then draw certain shapes. That also works, but we will go with code, and that's yeah, when you today hear generative art, you usually think of code and art. Yeah, as I already said, there are different kind of input types you can use. You can use random numbers. You can also make interactive generative art so that the user can generates the input, for example, with a Kinect, and you can scan the body pose and use that as input. That also works. You can also use completely different sensors that don't have to do anything with users. Let's say you have, I don't know, maybe a water sensor in your plant. That could also work. Or maybe also any different kind of data. Doesn't need to be sensors. You could also connect to large databases like Wikidata and draw information from that and use that to generate your art. So the generative models that you write, they can have a lot of different parameters. This can either be like binary values, you can either use rectangles or circles, something like that. This can also be a range of numbers, and usually you want to set a fixed minimum and maximum. So you find out, I don't know, maybe circles should at least be a certain size and should not get bigger than another size, so that it still looks good in some way. So this is something you have to figure out. Yeah, and when we're already at figuring out stuff, there's one important thing that I want to tell you about generative art. When you imagine the space that you are in with a generative model, you have basically two spaces. There's the possibility space. That is the space of all possible outcomes that you can do with your parameters and your settings. So every permutation is a dot in that space. And you also have that generative space. This is usually a subset of generative outcomes because you have some certain constraints that you put on. Let's say when circles are small, you make them blue, and when they get bigger, you make them red, something like that. And for generative art, there's a very important thing to consider. How large should your generative space be? Let's look at the two extremes. You can make it super big, so that it's basically the possibility space, so you get all permutations. This has the positive side that you get a lot of different results, but they might get super boring, or like the results get uninteresting or mushy, because like you throw just random stuff there and hope that it looks good in some way, and often it doesn't. It gets sort of boring. The other extreme would be that your generative space is very small and very defined. Has the positive side that you are very in control on what you generate and how it looks, extremely in control, maybe even so far that you only get one result. And that makes it boring to use, right? Because the fun stuff on generative art is that you get different sorts of outcomes, and you lose that when you make the generative space too small. So you need to somehow find a nice way in the middle where you have a nice variety, but all the results still look interesting. Before we start with coding, I wanted to show you some of my work to give you a bit of inspiration on what is possible, and maybe you can already find a bit of a certain path or certain thing that you're interesting to do later. The first project I want to show you is called GenChair. And I found a paper that was really interesting about how you can simulate the vein growth in tree leaves. And that gives super interesting pattern. And that rule set, that algorithm, is actually super easy to implement. And that's what I did. And to make it more like a leaf, you would put it in a leaf shape, but in my case I wanted to create a chair out of it. So I let these veins grow inside of a rectangle shape and then just threw that onto my CNC machine, which actually took quite long. So the back side and the seating plate took 5 hours each to cut out of my CNC machine. And when I put that together, I ended up getting a really interesting chair made out of thick birch plywood, and it looks quite fragile, but actually it's really sturdy. And I think that's a nice example that you can also use sorts or simulation to create generative art. It doesn't need to be like a super hard-coded rule set that you came up with. It can also be, you can also use some sort of maybe predefined simulation tools that usually works great. It can also be like gravity simulation or something like that. What I also like to do a lot is working with pen plotters, and this is also the reason why I started working with Paper.js, because there are a lot of awesome tools for creating generative art, and I think the most well-known are Processing and P5.js, and they are extremely great tools, and they have awesome communities with awesome learning materials. The one point that I was missing when I started getting into generative art was a very good export for SVGs or vector graphics. Because as you can see, I work a lot with machines that need these paths to cut along or draw along, like CNC machines, pen plotters, laser cutters, and all that stuff. Also 3D printing usually benefits if you have a nice DXF file, for example, that you can work with. And that's why I started using Paper.js, and that's also the tool I want to show you today. And this project that you can see here is called Overflower. It generates some sort of flowery images, maybe looks a bit like succulent plants. And what you can see here is what I talked about earlier about the importance of choosing the right size of your generative space. You can see that these flowers, they look quite different. Some have pointy leaves, some have more round leaves. There are different filling patterns. They are placed in different locations in their square, so they look quite different. But they also, you can see that they belong to the same model, and that's a nice feeling that I usually want to create with my artworks. That you have that you can generate a nice row of different images. They look like they belong together, but each one is interesting on its own. That's super important to me. My latest project is called Pico Planet. And yeah, I like a lot to experiment with different materials and how I can transfer these digital artworks into the physical world. And with this project, I tried to put generative art on PCBs. And it was a very interesting task for me, because for each new material that you experiment with, you need to find out prerequisites on how you need to prepare your digital file so that it's easy to process it in the processing path that you choose. In this case, I'm not sure if you maybe have looked at a PCB, you have different layers. You have these copper layers, then there's a solder mask on top, and on the solder mask there can be a screen print. In this case, that's the white screen print. And I want to somehow utilize these different layers because different combinations give different colors. For example, with Pico Planet, you can see these swirls in the background, and the lighter swirls are a combination with copper and solder mask, and the dark background are places where there's no copper under the solder mask. So you can play with that. Or for example, these little sort of yellow stars, they don't have layers on top of them at all, so it's only the base plate, and you can use them to shine light through the PCB. So always think about what your end product will be. You have similar interesting cases when you use pen plotters, because when you create digital paintings, and for example you have a circle with another circle on top, and they have a fill color, you can just draw them on top, and one will partly overlap the other. That's totally fine. If you put the same SVG later on a pen plotter, you will have problems with that overlap, because both circles still exist, so both circles will be drawn completely, and you need to find a way to cut out certain shape paths so that they are not drawn later in the image. So this is all stuff that you need to think out, in the best case, before you start to write your code, or maybe you need to refactor that later. What I can also highly recommend is using generative art in the creation of event corporate designs, because you can also not only publish a design document with all the colors and stuff that people should do for their slides, but you can also create a generator as a tool and give all participants this tool to easily create their own logo version or their own presentation slide backgrounds, and that automatically fits the corporate design of your event. And this is a very interesting thing to see when people start using these, and they like to use it because it's either fun to use, for example, or it's just a convenient way for them to get their own images. But when they start using it, and a lot of people use it, the whole event gets more, like corporate designs, it gets a more community feeling. And if you make it easy for people to get this community feeling by conveniently making their own images, this is usually a huge step, and people will start, printing their own t-shirts or their own merch stuff with their own variation of the logo, and this is usually a super fun thing to see. And for the last years I did this for Chaos Communication Congress, and made generators for people to use, and it's always great to see how people use these images in their own creative ways. One super quick last idea that I want to give you, what you can do with your generative piece, and also maybe with a generator that we will write at the end of the day, is to make it into a Twitter bot or a social media bot. Doesn't need to be Twitter, of course, but it's this very interesting thing to experience, because you give your art a very casual way to be viewed. Like, people can just subscribe. Let's stay with the Twitter example. Can just subscribe to the Twitter feed of your creative Artbot, and every now and then, every few hours, a new image will be created, and they can just watch it and can comment on it. And this is a super, open and public way to show your art, and also it's a very nice way for you as the creator to consume your art, because I guess you will also follow your Artbot, and when you scroll through your timeline, you will see a new image, and it wasn't you who had to push the generate button. So it gives always a nice warm feeling to your heart when you can interact with your own art in a very easy way and you don't have to interfere a lot. So that's all for the beginning. I hope this gave you a bit of inspiration, and we will start coding now. To do so, please go to Paper.js.org. This is the JavaScript library that we will be using, and there are 3 links that might be of interest to you. One is the references link, where you can find all the documentation. There's also a link called tutorials, which gives nice written short tutorials on different topics, and the most important one is the sketch link, because Paper.js has a great online editor, and this is where we will start now. So in this quick generative coding example, we want to create a grid made out of rectangles, and these rectangles should change along the axis, so x and y axis, and also some stuff diagonally. I prepared certain steps in the coding process for you so that you don't have to watch me writing down all the code, and I can better explain you what we do and how it works. So in the first step, we end up with a red rectangle. Paper.js has a class that is called path, and that basically holds every kind of vector graphic path that you would usually use, but it has also some nice predefined forms of paths, for example rectangles, and these rectangles, they need some certain information so they know how to look. Rectangles need the position, in this case that's the top left point, and also the size, so how big the rectangle should end up being. In this case we placed it in position 8080, and the size, that's a bit hard to read, the size is 50 by 50 units. With vector graphics you usually don't work with pixels, it's more units, and sometimes also depends on the exports what the units end up being with. Sometimes it might be millimeters or different stuff. This rectangle also needs some styling information so that it's visible. In vector graphics you have usually 2 main options to style. You have the fill color and you have the stroke color, and also the stroke width. And these are just set here with the attributes stroke color, width and fill color. And with Paper.js it's really nice that you, for colors, can use basically any type of color descriptions you know from CSS. So you can use the CSS color names, you can go RGB or HSL, basically anything you want. And to make this a quick example, I just use the color strings black and red, and I set the stroke width to 2. So when I run the code, you can already see the result. We get a little rectangle. So let's take this one step further. We want to make a grid out of the rectangles. So you can basically choose any grid size you want to make this a bit easier to look at in the recording. I choose a smaller grid with 6 by 6 rectangles. I put this in a separate variable so that we can reuse this later better. And basically we just take 2 for loops and make a grid. I didn't change much. Interesting parts is just the placing maybe, so you can use the x and y coordinates to place it in a nice grid. When they have the size of 50 by 50, we maybe want to have a bit of space between the rectangles, so I choose a position that is a bit larger. When we want to decrease the space between the rectangles, we can also just decrease these numbers and then it gets smaller. Choose it as you like. I think the 80 by 80 looks quite nice because later we want to manipulate these rectangles and it's nice to have a bit of space between them. And then there's also one really nice function. Paper.js has a color class, and this class has a random function, so it just gives you a random color. That's super nice and super easy to use. But if you now look at that rectangle grid, it looks a bit messy, right? Like you throw a lot of colors in there in one place and it looks a bit messy. It might be nice to change the colors later on, but first let's start to manipulate the shapes and forms of these rectangles. In the next step, I start to scale them along the x-axis. That's also super easy to do. You can scale a path just with the scale method, and usually you might start with, because we want to make them bigger, we can just go with our x-axis coordinate divided by the number of rectangles we have there. But if we do that, we will lose the first row because we start with 0, because x starts counting with 0, in this case at least. This is why I added 1 to that x here, so that we start with a small rectangle and it doesn't get invisible, and then we grow to the original size. The next step we can then do is rotate the rectangles. That's also super easy to do. There's a rotate function that takes degrees. And in this example, we can maybe just go through that step by step. So if you just want to rotate it more along the y-axis, we can, for example, just throw in a y in there. But y we just count from 0 to 6, then we end up with 6 degrees. That's not that much, but we can just add some factor in there. For example, let's say we take it times 3. That's also, it rotates a bit, but it could be more. And we could also maybe make it more fancy and just throw in our grid size in there, for example. That rotates it even more, so we end up with a 6 in the end. And to make it even more interesting, we can throw in a random factor, for example. And that's more or less what I did here in the beginning. We have our factor, we have also a random factor, and also we always add a certain number, because if we would not do this, we might end with a 0 overall, because mathRandom can give you a 0, and that would make the whole term a 0. So we always want to have at least 3 degrees and then maybe more. And that looks quite fun if we press play a couple of times here. That looks good. I think we can go to the next step and play even more with that sketch. Let's get some colors in there. This is what we want to end up with. We want a color gradient from the top left spot in our grid to the bottom right. And we choose 2 random colors to do so, and we need to calculate the steps from one color to another. So let's figure out how to calculate that. First, we take 2 random colors. Like here, that's what you have already seen, that's nothing new. The nice thing with Paper.js is that that Paper.js uses a nice way of operator overloading. So you can just use plus, minus, divide and stuff to add or subtract vectors. And colors in Paper.js are also basically just vectors in their color space. So what we do when we want to calculate a gradient is we want to calculate the vectors in the color space. So first we have color 1, color 2, and we need to know the little vector steps that we can iteratively add on to make that gradient. So this is what the color dist function does. So we take the large vector from 1 to 2 and then divide it by the number of steps we need. So how did I come up with that number? Super easy. We have our grid. Let's see how many colors we need. So because all rectangles that are diagonally on the same line, they get the same color. So this is one color, these rectangles get one color, these two. So we have 1, 2, 6 until we are in the middle, and then we need 5 more until we reach the end. So it's always the grid size plus grid size minus 1, and that's why we end up with this number. So what we now have is that small vector, and I want to save them in an array so that I can later just grab the calculated color. To get each color vector, we can always go with color 1 and then add the small distance vector on top iteratively. And then we just need, like here, set the fill color in the right place instead of the random color that we took before. That's basically it, and it gives you a nice gradient, and I think that really looks really interesting, makes it way more pleasant to look at. And often picking colors in generative art can be quite hard because two random colors often don't match very well, but if you make them into a gradient, they suddenly start to work quite well. At least in most cases, there's still problems if they are too similar maybe. That's maybe an idea if you want to work further on that code to make sure that colors are not too similar, or maybe choose colors that are on the opposite side of the color spectrum maybe. That's everything you can do later. Okay, next step. We want to add a bit more interesting stuff to the image. That's basically more or less the last step that we will do. We add more rectangles that are not filled, but are a bit not distorted, but rotated differently and also scaled differently. So that makes it more interesting to look at. And there's not a lot we have to do to make this. We just add another nested loop. This is this loop that counts I until it reaches 2, like 3 times. So we add 3 rectangles. The first rectangle, this is this one here, that gets the fill color, like in the step before. The others don't get a fill color, so they stay transparent. And then we need to play a bit with the rotation and especially the scaling. To be honest, we don't need to change a lot, or actually nothing with the rotation, because it also already has that random factor, so they will always look a bit different. Nothing much to change here, but the scale factor. We can add the I in here, which is really nice. So the scaling from each stacked rectangle is already one step ahead, basically. This is why they look a bit bigger, like this rectangle, this colored rectangle now becomes also the same rectangle size from the next step and the step after that. So they get bigger. And that's basically it. When we let that run a bit, that makes it really interesting. And then there's one last teeny tiny thing that we can do. Currently you can see that the whole sketch is basically glued to the top left corner because of the way we calculate the positions. And it's easy to do it in that way, but maybe we want to center it to make it look a bit more appealing if you would integrate that to a website or something. And there's an easy thing to do that. We put everything in one group. This is also a Paper.js class, and every path object that we create, we need to add that to that group. That's done by add child, and in our case we just throw in the rectangle. And now comes the fancy part. We can just set the group position to the view center. The view is also an object that is given by Paper.js, and that's like a super helpful line to just center stuff. Can highly recommend using that. And that's how we end up with our nice rectangle generative art piece. Please feel free to experiment more with this code example. I prepared a link for you which is called example.bleeptrack.de. That link will bring you directly to this Paper.js sketch. By the way, it's super nice to share them because the URL encodes the whole code, so the links get quite long, but you can share your whole project with that. So yeah, just go there. You will find the example we created together today. And yeah, feel free to experiment further with it. Go crazy. Experiment with colors or certain ways to choose 2 colors for the gradient. Maybe you can also play with opacity or blending modes. There's a thing we didn't talk about at all, which makes really nice effects. Maybe you know these blending modes from Photoshop, where you can like have a multiply layer, so you can mix different half transparent layers together to get new colors. That's super fancy. Maybe make it interactive or animate the rectangles, make them pulsating, or create shapes by scaling in an animation, or make it interactive by, I don't know, maybe people can choose their color or can drag some rectangles around or change the rotation or something. So yeah, go crazy, experiment a lot. That's the fun thing with generative art. Just try a bunch of things that come to your mind and see how it goes and where it takes you. Have fun coding, and I hope to see you soon. If you have any questions or want to reach to me, you can find my contacts on my website, bleeptrack.de, or you can also find me, for example, on Twitter or Instagram or other social media channels by the name of bleeptrack. Yeah, have fun at GitHub Universe, and see you soon. Bye!
Good morning, everyone. So my name is Alexandre, and I'm going to be your host for this session. And today I'm going to be talking about Nanu, and that's a creative coding framework that has been written in Rust. So I'll try to keep this interactive in the sense that I'll try to do a live demo of working with the framework so that you can get a feel about how it feels to actually work with Rust and this wonderful framework that is Nanu. So just to give you a brief introduction about myself, I'm actually working for Sony. I do a lot of things, and I work mostly on the future of entertainment and how we can use new technologies to create new experiences. And today I'm going to be talking about the creative coding part of my activities, where I've actually been releasing daily animations for the past 4 years or so. And in the last 2 years, I've been using exclusively Nanu. So Nanu is a creative coding framework that has been written in Rust. So if you're not familiar with creative coding, it's the use of computers and technology to create interactive pieces of art, installation, or whatsoever. And you might have heard of processing or open frameworks, or even Cinder for what matters. So you have a lot of different frameworks out there, but the only one that I know of where you can do a lot of interesting things in Rust has been Nanu. So Nanu has been developed by the wonderful people behind Mindbuffer, a design studio, and they're doing like awesome installation using the framework. Personally, myself, I'm using only for doing graphics so far. And you can even look at the homepage of the project, and you can see a lot of my sketches here. I'm not part of the team. I'm just maybe a heavy user of the framework. So you can find me on Twitter, Instagram at the MacTutree handle, and I post my animations every day, so you can get a feel of what the framework is able to do just by looking at my collection of sketches. So that's going to be it for the introduction, and let's jump into the live coding. So if you're not familiar with Rust, I'll try to keep things as simple as possible. But if you're familiar with Rust, please tell me where I'm wrong, because I will obviously make a lot of mistakes along the way. So we're going to use Cargo, obviously, the package manager for Rust, and we're going to ask Cargo to create a new binary application for us. I've called it Universe because I'm completely lacking any originality here. So in our Git repository that Cargo has made for us, we have the cargo.toml file that is already here, and that gives us all the information that we need to work with our project. So in Rust, when you want to add a dependency, you just add the name of the dependency you want to use, the number version, and then you're good to go. So that's wonderful. And when you try to run your project using Cargo, Cargo will fetch all the dependencies, all the libraries that you're using, and compile everything for you. Just a quick note here, on my machine, I've set up a cache of all the libraries, so that's why it's super fast. If you're trying to do the same on a fresh install, it will take a few minutes here. So if I just run the basic hello world, it's not interesting. So I'm going to cheat here just once. I'm going to take the template application source file that is available from the Nanu framework, and I'm going to put this into my main file. So let's look a little bit about how you would use Nanu in an actual setting. So I'm going to try to create something interesting within the time frame that I have. So I might go a little bit fast on some points, but I'll try to explain as best as I can how this works. So in our main function here, we're going to just create a new Nanu application that will start by making a model. And a model, if you're familiar with the model view controller design pattern, this is what Nanu has been designed with. So you start by creating a model that is just a data structure that can hold all the data and all the information that you want. Then I'm asking Nanu to update this model every time we need to refresh the screen. And then finally, in the view function, we are able to show a representation of our model to the screen. So now that I have this in my main file, if I try to run this, we'll hopefully get something that looks like this. And this is the beauty of using a framework like Nanu. Nanu is taking care of all the heavy lifting for you. In the backend, it's using the latest graphics technology. So it's using here Metal via WebGPU. So if you've heard of WebGPU, you're in good shape. It's basically the future of the graphics API, where you're trying to use the GPU to their fullest, and you're not held into the past. You also have window management. You have event handling. Everything is done for you. And the nice part about Nanu is that Nanu is not hiding a lot of stuff behind a complex structure that you're not able to access to. So if you really want to, you can get to the gritty inner working of the framework. So we're going to try to modify some interesting parts here. So I have here my background colors. I'm going to say it's black. I want to draw a circle. So we use the ellipse function. And I'm going to just offset my ellipse here. So to make it a little bit easier to see, I'm also going to resize my window to a bigger square. And when I run this, I should get a black screen with a white dot just off center. So this is how you would start working with the framework. You would start to use the existing function and try to work around this. So let's do a little bit more introduction stuff. I'm going to try to do a circle of circles. So I'm using a for loop here. In Rust, you work over ranges. So that's how you define ranges. I'm going to define the angle as my I value here that I need to recast as a float, because it's not a free operation to cast a variable into a different type. So I'm dividing it by 10, multiplying it by tau. You should never use pi, by the way, side note. And I'm just saying, if you remember your basic geometry classes, I'm now asking Nanu to draw 10 circles that are laid out over a circle. And we should get something like this. We have our 10 circles that are arranged in this simple circle here. Now, if we were not using computer codes, we would not be able to do animation. So let's add time into the mix. So I'm going to define time using this elapsed frame functions. Of course, Nanu can give you the time as the amount of time that has been elapsed from the beginning, but I prefer to use actually the number of frames, because when you do heavy stuff, it's easier when you are just rendering frame by frame. And I'm just going to add the time value to my angle here. And so far, so good. The compiler is agreeing with what I've been doing so far. And that's the power of Rust. If the compiler agree with you, then you're good to go. You're pretty much sure that your code will run very fine. So that's really the basics. How do you work with the framework? You just have a lot of those functions that are designed to be written in this, where you add more stuff at the end of whatever you're doing. And then we're trying to go from here to a little bit more complex example, where I'm going to add a little bit more interesting pieces here. So in order to do this, I'm going to define a new structure. I'm going to define something that I will call things, because yeah, it's going to be interesting to just work with things. And I'm defining those things are just having a position for now. So they have a position. So I'm using this vector2, that is a two-dimensional vector, the way you would represent a point in space. And then I'm going to define the constructor for my thing. And this is going to be a public function that I'm going to be calling new. And this will take another vector as its input, and it will return self. So self is the keyword that you use in Rust to represent the structure that you're working with. If you are using JavaScript, you might think that this is similar to this, but no, this is far better than this. So hopefully you find my humor pretty bad when I'm doing those kind of weird references to bad JavaScript. So here in my constructor, I'm just declaring a new struct, defining its position to be P. And in Rust, when you're not using the semicolon at the end of a logical line, then it returns that. So that's how this function is returning my thing. So now I have my structure here that is defined, and the compiler is not complaining. So if I were to run this, I will get my circle again. And since I'm not doing anything with my things right now, this is still the same. So I'm going to use my model here to store a lot of those things. So let's say that in my model, I want to have a dynamic vector of my thing. So that's how you would define a vector of type thing in Rust. And when I'm just initializing my model, I also need to put my things here. And I need to define what things is. So I'm just going to say that thing is going to be a new empty vector. I have no errors right now. And that's the power of the compiler here. I'm not declaring the type of things, because if I'm using things in my model, it can only be a vec of thing. So the type here has been inferred by the compiler to be a vec of things. So if I'm still not putting anything in my vec, it's pointless. So we're going to try to add one element to our vector. So I'm going to define a new one. I'm going to try to put it at the center, just using the macros that Nanu provides. So here I have the vec2 function that just creates a point in space. And I'm trying to push that into my list of things. And now, here we have an error. And I'm going to show it on the left screen so that you can see it better. This is something that you will encounter a lot when you're working with Rust in the beginning. Rust is going to make sure that you are really willing to do the things you are asking it to do. And here, I'm asking it to mutate the things. And when I'm declaring things here, I'm saying this is by default an immutable variable. So Rust is saying you're trying to mutate something that should not be mutated. And that's where the safety that people associate with Rust is coming from. The compiler will complain a lot about what you're trying to do and will guide you to make it safer, in a sense. So in order to solve our issue here, we're just going to declare things as immutable. And then everything is fine. It works. We can still go on and compile things. So I'm going to represent my model now. So I'm going to get rid of my for loop here. I'm not going to draw this bunch of circle. I'm going to iterate over my list of things. So I'm going to start by asking an iterator over my list of things. And I need to rename the variable name, because if you are not using a variable in Rust, Rust will also complain that you're not using the variable. And that's a potential for errors. So if you want to get rid of this warning, you need to use an underscore in front of your variable name. So that's why you have here an underscore. So if I erase this, the compiler is happy. It's able to find my thing. So I'm going to draw an ellipse right now. And I'm going to put it at the position of my thing. I'm going to say it's going to be a smaller one. Let's say 5 points. And I want it to be white again. And now I should get, if you've been following along, just 1 point in the middle of my screen. And that's fine. That's what we wanted. And it's boring. Yes, it is. That whole thing starts by being boring. And then we add more until it's interesting. So we're going to add a lot of those things. So I'm going to try by adding a constant here. So I'm going to say the number of things is going to be inside char, and I say, let's go for 2,000 of those things. And I'm going to iterate over the range of those things. And I'm going to add a bunch of new things all over the place. So if I were to run this right now, I would have 2,000 things at the center of my screen. So it's not really interesting. So we're going to spread those things evenly over the whole screen. So for this, we're going to use the random function. So let's say random will return me a float between 0 and 1. So I'm going to center this, and I'm going to multiply by the size of my screen. So let's say this is what we want, and then, oh, the compiler is complaining again. Let's look at the error right now. So the compiler is saying that it cannot infer the type that is required for using the function random. And that's also, again, a nice feature of Rust. You can have multiple definition of the same thing, but when you need to specify, you need to be really explicit about which version you want to use. Because when you're saying random, it doesn't mean that you want to float. It could be a bool, it could be an integer, it could be anything else. So you need to use this slightly non-familiar syntax for me at the beginning to ask for the specific version of random that you want. So this is going to ask for a float that is between 0 and 1. So if we run this, we should be fine because the compiler is not complaining. And then we got our bunch of points that are shown all over the place. Boring again, we'll get to the interesting part soon enough. So I hope you've been following along so far. I'm just creating a lot of things here in my model. And in the view function, I'm trying to display them. So now we're going to add movement. We're going to try to work with the animation part of what makes creative coding interesting, especially for myself. So when we are looking at our code right now, you might think that in your loop here, you could be able to just do, okay, I want to move the position of my things just by a small vector. But the compiler is saying, yeah, no, you can do this. This is not how you're asking the code to do. We're asking to mutate our thing. We're asking it to change, but we don't have a mutable reference. We're not allowed to mutate this because when you ask for an iterator, you're not asking for a mutable one. So you would ask for a mutable one by using the itermut function. But the problem is our model right now, when we look at in the definition of the view function, we're only having an access to immutable reference to our view, to our model. And that's by design. The people behind Nanu are following the model view controller pattern, and you're not allowed to mutate your model in the view function. The view function should only represent your model. So if we want to modify our points, we need to use the update function. So it's going to be cleaner in a way where everything that is related to modifying our model is going to be in the update function, and everything that is about showing it is going to be in the view function. So I'm going to clean my view code so that it's back to showing the ellipse. And in my update function, I'm just going to ask to mutate my things and make them move just slightly to the right. And then now I have points moving to the right. It's super boring again, but we'll get to the interesting part. And I hope you understand why Rust is interesting to work with, because it will put a lot of safety checks for you when you're writing your code. So let's say we do not want to work with this weird slightly displacement to the right. Let's say we want to move things randomly. So I'm going to grab my random code here, and I'm not going to move by that much. I'm just going to move by just a few, just 1 pixel, 1 point wise per step. So then you can see maybe that my points are slightly moving, and it's called Brownian motion. It's the state of particles when they're moving in a liquid, for example. It's boring because it's lacking direction, it's lacking scale, it's lacking contrast. Everything is moving at the same rate, and it's not showing any particular points of interest. The tricky part about creative coding is finding interesting points in something that is procedurally generated. And I'm going to show you one way to do this. So when we're talking about pure randomness, it's not really interesting because randomness is boring. So we want something that has more meat than just pure randomness. And we're going to use for this noise. And noise, it's basically like gold in form of a mathematical function. So I'm going to define a noise function here. I'm going to use Perlin noise that is named after Ken Perlin, the professor at the NYU. And he actually won an Academy Award for his work on this. So I'm adding the noise to my model, and since noise is not by default included in the scope, I'm just putting everything that I need in scope using the use keyword. So now I have noise, and noise is a mathematical function that will return me a smooth random value when I'm trying to ask for something. So instead of moving my points around randomly, I'm going to move them along the value of this noise function that is there. So I'm going to get my noise generator, and I'm going to ask for the value of the noise field at the position of my thing. So I'm going to ask to create a new vector here that takes the position of my things. And since I want a two-dimensional displacement, I'm going to use three-dimensional noise. So that's a trick. You can always get interesting results because you have more dimensions to play with. The compiler is complaining again because the noise crate that Nanu is using is expecting doubles instead of floats. So this is going to be dirty. So pardon me, excuse me for doing this right now, but for the sake of time, I'm going to do a dirty fix here by just converting everything to doubles as we need to, and converting them back to float afterwards. So now I should be getting points that are moving, not completely randomly, but just along this noise function that we asked for. And it looks the same. So this is a huge, easy to make a mistake in the beginning. It's because when you're dealing with noise, noise is not designed to work along huge spaces. Noise were designed to work along very small spaces. So here, when we're talking about the range of positions that we're looking at, so share is going over the whole screen, it's too big. Noise has been designed to work with very small ranges. So again, I'm going to do a very crude fix to scale everything down to something that works with the noise function that we're using. And then suddenly we have, we have structure, we have direction, we have movement, we have interesting things happening. And I'm going to rerun this again because the interesting things happen in the beginning when you start to see the points going along. And then when they reach convergence points, we are lacking this contrast and direction again. So we're going to work on fixing this and making things look a little bit more interesting. So I'm going to use the cheapest trick in the book. That is, if I'm not on the first frame of my animation, that is, if I'm not starting fresh, I will not erase the background before drawing the following frame. So this might sound complicated, but it's really easy. I'm just drawing over the previous drawing all the time. So suddenly we see those lines that are moving around, and we see history, we see the past. So we get a feel about what was happening before, and it starts to look interesting as an image by itself, but the animation part is lost. So the second trick that you will use all the time when you're trying to do something like this is you're not trying to erase the past, you're just trying to give a slight hint of the past. And in order to do this, we're going to just draw a black rectangle. So in Nanu, you would use something like this to define a black rectangle. That is, if you're following along, I'm using a very transparent black. And this looks like this now. So I am drawing over my animation with something that is almost black all the time. So I get this fade to black effect for free, basically. And this is where Nanu shines, because Nanu is using float precision for colors, but not for the whole color itself. For every channel, for each channel of color information, you have a floating point precision. All the other frameworks that I know of are not able to do something as pure as this. So, yeah, Nanu, go here. So now you can see that the interesting part of this is the beginning. I hope it's not that choppy on your side, but it's really showing the beginning is where we see the noise getting here in, and that's the interesting part. So we're going to try to do this in the remaining minutes that I have. I'm going to try to show the lines and not just the actual position. So I'm going to change my things here to not be just one point, but going to be a list of points. So I'm going to create a list of points here that is going to be empty. I'm going to add my initial position, and I'm going to declare my structs at something like this. So right now I'm just saying that my things now are a list of position and just not only one point. So I also need to update how I'm making those things move. So I'm going to take the last position. It's going to be the same position, and I'm going to use the head of my list for this. And I'm going to say that the new position is going to be the last position plus the same displacement that we're using. And of course, I need now to refer to this last position and not the position of my thing. And I also need to push back my new position. So I'm going to insert it at the head of my list, something like this. So what I'm doing right now is I'm just adding this new position to the list. So the thing will hold the ever-growing list of positions. So I'm going to represent this using the polyline function of Nanu that is designed to do exactly this. So it's going to take a list of points and it's going to show it to you. So excuse my pretty fast explanation of what polyline is doing. Polyline wants to hold the positions, so you cannot actually give the positions of the things directly to the point, because Rust will say, no, you cannot move things around. So I'm cloning all the information here. And then if I try to render this, we see a bunch of lines that are being drawn on the screen. And if I don't stop here, you might guess that this will crash eventually because I'm just adding more and more points all along the way. But this is interesting because we see the structure of the noise. We see some things that are interesting. We start to see where the noise is driving our points around. And it gives you a feel about the structure of what we're using. We have interest points and everything. So I'm going to do one final trick just to spice things up, and I'm going to speed basically the drawing. Here you can see in our update function, we're just going one step forward. I'm going to say, screw this, let's go for 50 steps. I'm going to say, I want you to go 50 steps forward, and we're going to draw this all the time. And I'm also going to reset my thing every time I'm going into a new frame. So in order to do this, I'm going to clear my positions list, and I'm going to add a new position at random. So I'm going to define a new vec2, and I'm going to use the same code that I was using to create the things in the first place. So now I am actually creating a new empty list of things each frame, and I'm adding a lot of those lines all the time. And I'm asking them to move along my noise field for 50 steps at a time and drawing those lines in white. So let's have a look. Suddenly it's going to be completely different. We have a grayscale representation of our noise field right now. If you have the time, the code is going to be available, of course, on GitHub. Please try to execute the code on your machine so you can see the animation in its complete glory. And this is what you can get when you're trying to represent something as complex as just one mathematical field along the way. I'm going to add a final trick just to convey the point that when you're working with creative coding or something like this, you're allowed to do a lot of weird stuff that might not make a lot of sense. So let's say I'm going to change my parameter here, my scale parameter here. So I'm just going to add the time. I'm going to take the cost of the time. I need to use doubles because Rust. And I'm going to make it a little bit slower. And this is how I need to erase the underscore. Rust, again, is preventing me from hurting myself. And now it's subtle, but you can see that the scale of the noise is moving. So that's it for my talk. I hope that you enjoyed it and you kind of followed along how this is working. I am available to chat in the Matrix channel for Nanu. And if you have any questions, I'll be there to answer them. Thanks a lot and see you later.
I'm Harel Savakis, a game developer and technical artist from Athens, Greece. I am here to give you a gentle introduction into the magical world of shader coding, and I hope that in the next 10 minutes I will be able to demystify some of the black magic that surrounds the concept of shaders. I would like to thank GitHub Universe for this wonderful opportunity, and I guess let's get you started with shaders.
Let's start with the very basics. What are shaders? Shaders are small programs that define how objects are shaded and rendered on a screen. They run directly on the GPU because it's way faster for them to do so. There are different types of shaders like vertex shaders, fragment or pixel shaders, and geometry shaders. How can one create shaders? Well, game development environments like Unity and Unreal Engine provide node-based tools for shader authoring, like Unity's shader graph and Unreal's material editor. Shaders can otherwise be made using code, specifically using shader code languages like CG, HLSL, and GLSL. What will we be creating today? We'll be making a simple pixel shader using GLSL. We won't be dealing with any geometry, lights, or any other 3D elements. Our scene will be completely two-dimensional. This demo will introduce some very basic shader concepts and functions, and we'll be using ShaderToy for it, which is an online platform for creating and sharing GLSL shaders. Before we get into it, here's a glimpse of what we'll be making. Let's now jump into ShaderToy. This is what you see when you first make a new shader in ShaderToy. The color of your output is determined by what's in the frag color vector. We can see that better by setting our color to a fixed value. And now we have our color. Similarly, we can set the red and green channel of our output to match the UV coordinates in order to visualize them. We can do this like so. This way we can see how the UVs behave for each axis. On the bottom left corner, both components are 0, and on the top right, they are both 1. We can also see that the red channel, which corresponds to the x-axis, grows from left to right, while the green channel, which corresponds to the y-axis, grows from the bottom up. Something to note is that shaders have a neat feature called swizzling, which allows us to arbitrarily use components of other vectors to compose new ones. So this line could also be written like this. Or like this. Let's now see how we can use our coordinates to make the simplest shape we can, a circle. A circle in shaders can be drawn by measuring the distance of any point from the center of the circle. Using our UV coordinates, we can express that as the length of the vector which goes from the center to our current UV coordinate. Assuming the center of the circle is also the center of our UVs, we can write that like so. Using only one value in a multidimensional vector constructor like that applies that value to each of the vector's components. Let's see what this distance looks like. We're kind of successful, as the color gets darker closer to the center because the distance is closer to 0. But the shape is stretched, and that's because our aspect ratio isn't really square. We can fix this by multiplying the x component of our UVs by the screen's aspect ratio. Before we do that though, we need to bring our center to 0 by subtracting 0.5 from uv.x. After we multiply by the aspect ratio, we then add 0.5 again to bring our center back. It's looking better already. However, this is technically not really a circle, right? It's just the distance function that can produce a circle. In order to get an actual circle, we have to specify which pixels are within a specified radius and which ones are outside. Here's where a super useful function comes in, the step function. Step will take two parameters, and if the second one is smaller than the first, it will return 0, otherwise it will return 1. So if we have a radius of 0.3, we can create our circle like so. Now this is a circle, but this has the opposite effect because pixels closer to the center are darker, right? So to invert it, we can just invert the order of the parameters. This is what we want. Let's now see how else we can use math to get some interesting shapes and forms. We'll come back to the circle later. We'll be using a very well-known math concept, the sine wave. We can pass the uv.x to a sine wave and multiply it by some number, say 5, to increase the wave's frequency. Now, this doesn't look like a sine wave per se, but try thinking of it as if you're looking down on a surface of which the height follows a sine wave pattern. To get a more familiar shape, we can use the step method again, but instead of using a constant number, we can use uv.y. This will result in the threshold increasing as the pixels get higher. We can bring this up a bit by subtracting a number from uv.y. We should reduce the amplitude a bit too. Most shader environments, including ShaderToy, provide a way to add motion to your elements by providing a time variable that increases over time. To get some movement, we can just add that to the sine wave phase. Let's make it a bit faster. It looks good, but it's a bit too repetitive. So let's add another wave to get a more interesting shape. Looks better already. It's more fun to have more of these though, so let's make a function. I'll just pass the wave generation code to the function and set the frequencies, speed and offset as parameters to that function. Now we can just call this function, so we don't need all this code anymore. Let's add some more and layer them in a way to fake some parallax motion. To do that, I'll add 2 more layers that are offset higher, move slower with different frequencies, and have smaller values. I found that these values work the best. We can combine the waves by getting the maximum of all the values. There's also a way to fake some blurriness on the further back layers, and that's by replacing the step function with smooth step. Smooth step works like step, but takes 3 parameters. If the third parameter is smaller than the first, smooth step returns 0. If the third parameter is greater than the second one, it returns 1. If it's between the first and second parameters, smooth step smoothly interpolates between 0 and 1 based on where the third parameter is placed between the other two. Let's see it in action. And we can now see that the edges have gotten blurrier. That looks good already, but let's add some color. We can set 2 colors and interpolate between them using the values of our waves. To interpolate between the 2 colors, we can use the mix function. Mix, or lerp on other environments, takes 3 parameters and returns the value of the first if the third parameter is 0, the value of the second if the third parameter is 1, and it linearly interpolates between the values of the first and second parameters based on where the third parameter is between 0 and 1. Mix can also be written like so. Let's also use our circle from before to invert the color of the pixels that are inside it. And that's about it. I hope you got a useful first glimpse at how shaders work. Thanks for watching.
Hi, my name is Mario, and today I want to talk about how to use Three.js to make kinetic typography effects. For those of you who don't know what Three.js is, Three.js is a 3D JavaScript framework that works with WebGL and lets you do amazing things. Things in 3D, also 2D. You can make or take advantage of the GPU to whatever your needs are. And well, that's pretty powerful by itself. Okay, yeah, let's do this. So I'll skip a bit of boilerplate for time's sake. And well, the premise is quite simple. We have a 3D object and we want to paste on top of the surface some kind of texture that has text. There are several ways to do it, but I found the most simple one just to use a texture. In this case, it has the word universe and well, sample it in on the texture. So for that, first we'll need to load the texture. Here, const texture equals new, create that texture loader that load image. And in this case, I'm going to pass a callback function just to fix some weird line artifact that happens in this case. It says texture.min filter. Okay, and instead of using a mesh normal material, we have to use a shader material to move things to modify the shape of the torus geometry. Did I mention that this is a torus geometry or a donut? And also change its colors. So for that, we use a shader material and pass a vertex shader, a fragment shader, and some uniforms where we'll define time so we can move things, and our previously defined texture. Texture. All right. Also, let's enable the transparent flag because we're using a PNG. We want to make things transparent. And yeah, for now, let's use 3 dot double side. So it also renders the inside of the donut. Before jumping to the shaders, let's update the time uniform. Forms.uTime value equals the boilerplate already has a clock variable, so we can get the time. And yeah, I think it's an error. And it's because, let's see. Yep. Can you spot the error? Because I'm not sure. Texture is not defined. Of course it's not defined, so sorry about that. Okay. Yeah, all right. So we have now this red ring or donut, and let's jump to the shaders. So a shader is a program that runs in the GPU, like blazingly fast. And we have 2 types of shader we're interested for this. We have a vertex shader that runs for every vertex of a object, and a fragment shader that runs for every pixel. First, let's jump to the fragment shader so we can sample the texture on the surface. So for that, we do vec4 color equals texture 2D. These are built-in functions from GLSL. Texture, and we'll use the texture coordinates called VUV that tell where to put the image pixels on the 3D object. So okay, so we do color, and yeah, we can see it right now that it says universe. A bit weird, but we can make it more interesting. And for that, let's repeat the texture with the UVs. So let's define UV that equals to the varying UV, and put UV here. and it's the same for now, but it starts to get more interesting when we use the function called frac, which takes the fractional part of a value, and it's perfect for repeating things. So let's do uv times 2 for now to see what happens. Yeah, it's repeating both in the x and the y axis. Let's use a variable instead called vector2 repeat. This vector2, and let's do something crazy like 6 on the x-axis, and 12 on the y-axis. So repeat, and we should see a lot of text. Oh yeah, it's starting to get better now. Oh, nice. Now let's add time to it, and for that we do vec2. I think it'll look better if we move it like this, and for that like this, and for that we need to pass time to the y component. Path. Yeah, looking good. We can accelerate the speed. Yeah, I'm even making more interesting. Before jumping to the vertex shader to move the shape, let's see we can like bend the text. And for that, I think we should do maybe that x plus equals sine of the y component. And this looks, yeah, this looks twisted. Let's change the amplitude of that. Yeah, I think it looks good. We could even add time here, and it would oscillate from 0 to 1, from 0 to 1. I'm sorry, from -1 to 1 because sine. Okay, that it started to look interesting to me. Even if we got in the middle, I'm sorry, in the inside of the donut, we could even take a screenshot of here, and it would look interesting by itself. Yeah. All right, so I think that's all for the fragment shader for now. So let's jump to the vertex shader. Like I said earlier, the vertex shader runs per vertex. Not sure if it means too much right now, but imagine it like it from each point that makes the geometry, whatever you pass here will affect that point. And I was thinking of maybe bending like some sort of rubber band or like old tire, like it's too soft. So for that, let's do this. Let's call this variable transformed that is equal to the position, and let's use transform here, which should affect nothing for now. But when we do this, transform plus equals sine of position that, well, transform this z component is plus equals the x for now plus time, well, u time, yeah. You should see something more interesting now. Yeah, I like it. Let's do y. Let's do y. Oh, nice. Yeah, I'm starting to like the result. So you can imagine you can tweak whatever you want here. And we're just using trigonometric functions for now, but you can see the possibilities if you use like noise functions and other crazy math stuff by itself. Let's see if we can add also the x component. Also, let's see if we could rotate the mesh, just to have another perspective for now. Mesh the rotation that we have to rotate the x. So it's the math dot pi times, yeah, a little bit, 7, 8. Yeah, it's I think I'm yeah, kind of. Oh yeah. Yeah, I think, yeah, it's looking good now. in my opinion. So yeah, I think this is it for now. You can imagine, like, you can even just using one texture can get you like pretty far in terms of visual or aesthetics. Imagine if you could like replicate this instead of using a torus, you could use a sphere geometry, a cone, box geometry, and having like thousands of box of geometries or instancing them could get you like a pretty interesting result. And well, this is just like a overview. I have another tutorial where I explain a bit how you can use, instead of just a fixed texture, using render targets, which lets you like dynamically change text. Imagine it as if you have a scene where you have text, and that text you paste it on the geometry, but that's another kind of soup. So that's it. I hope you like it. If you have any questions, let me know, and see you guys in the next one. Bye.
Hi, I'm Kate Compton. I'm better known on the internet as Galaxy Kate, and today I'm going to be showing you a tool that I made called Tracery and a website called Artbot.club, and I'll be showing you how to make a Twitter bot in just 10 minutes. A lot of people think that making a Twitter bot or making a conversational agent needs to be this whole big production using machine learning and advanced techniques, but it really doesn't. So right now I'll be showing you a technique from early on in AI called context-free grammars, which is a way for you to make expansion text in an easy way that you direct entirely yourself. So it takes as its input what's called a grammar, which is just a way of specifying symbols, which are kind of buckets of things, and replacement rules. So you can always replace the bucket with a bunch of the different replacement rules. So you can see right here, I've just got one symbol. This is called origin. This is where all the grammars in Tracery start off. And it's just hello world. It's not terribly exciting. So you can see I've got 5 different variants of hello world there, but they're all the same because we don't have any variants yet. So I can create a symbol. So I can make a symbol for world. And I can make some options for that. So maybe GitHub and world, and where I am right now, Chicago. And how do I use this symbol? So I can use this symbol by making a hashtag. So you just say hashtag world, and then you close it with another hashtag. Now you can see I've got hello world, hello Chicago, etc. These are all randomly rolled, so I have to re-roll them to see if I can have some variants. So, oh, there we go. There's the GitHub one. So on Artbot.club, this is kind of where your traces are. Traces are one particular walk through your grammar. You can see I've got 5 of them here, and they're just like randomly generated. So this is not terribly exciting, but I might want to say switch out hello. So what if we had another symbol for hello? So I can replace hello with hello in hashtags. And you can see that even though I haven't specified that symbol yet, Tracery is still okay with this. It knows that like sometimes you make a bot and you haven't actually finished all the stuff in your bot before you need to use it. So it's okay with just using placeholders right here. So you can see it puts those in the parentheses that I know how to edit, or that I know I have to go back and fix them. So hello world. And then I can go and say, all right, well, a couple different ways to say hello are maybe, hey, ni hao, hello, and hola. So now I've got hola, Chicago, etc. There's another neat feature in Tracery, which is you can have modifiers. So you might want to have hello, but I'd like to capitalize whatever comes back. So you can imagine, well, okay, maybe I can just do that here, and I can capitalize hey. Maybe sometimes I want to use this capitalized, and sometimes I want to use it uncapitalized. And so Tracery has this neat feature where you can just do dot capitalize. So there's a number of modifiers like dot capitalize and dot s to pluralize things. And I'm trying to add in some new ones that are useful. And so you can see now I have got hey, ni hao, etc. But today I wanted to show you making a quick bot that I'm going to call tea and a compliment. So it's rough times right now. People seem to need a little bit of happiness in their lives. So I'm going to make a little bot on Twitter that gives people tea and a compliment. So the bot maybe says hello and capitalize, and then says, here is some tea and a compliment. You can see, again, I haven't actually specified these symbols, but it's happy to just roll with this. So I can say T is maybe, let's see. You can see I'm creating some more replacement rules. Cup of flavor tea. So you can see we can embed these and nest them as deeply as we want. And maybe some chai, and maybe a bowl of matcha. All right, so we've got some different kinds of tea here. Let's see if we can get that flavor tea. Yeah, flavor tea. And so that I could specify some flavors. Like peppermint, ginger, cinnamon. All right, so now I've got like my cup of tea, and now I might want to have another one that says, here's my. So this is just giving us some practice here. So, what is my? Oh, and actually, the thing that I want to do with this tea is, you can see it's a little ungrammatical. I want to have a cup of tea. Oh, and maybe I'll say an ounce of coffee, or an ounce of espresso. That's better measured. So I've got some, maybe I'll just have an espresso. I just need to start with this, because you could see that if I said, okay, here is a tea, espresso is ungrammatical, and so we go back to our modifiers, and so we say t.a, and now it correctly puts a or an in front of things. So that's a neat feature. So yeah, we're going to make our quick complement. You have adjective, noun. And I can say maybe our adjectives, or let's do our nouns first. So our nouns are ideas, emotions, and let's see, eyes. So you have adjective eyes. So then I could have things like an adjective might be valid or lovely, maybe deep. Thoughtful. And here's a fun one. You can reuse a lot of your different rules in different contexts to get some interesting emergence. So I might say you have flavor, maybe rich flavor. Yeah, so now I have valid eyes, thoughtful ideas. Let's see. Yeah, and you have rich cinnamon emotions. So this is very complimentary. So I like this bot a lot already. I'll show you very quickly just one other thing, which is you can save things. So you might want to save something to use later on. So I might say, let's see, I'm going to save the noun. So I'm going to say my noun. It doesn't matter what you call this, but I'm going to stuff into it a noun. So any noun, and now I can say my noun. So this looks just the same where I'm using some noun, but I can say really very adjective my noun. So this will always come up with the same my noun. Normally this would be two different nouns, but yeah, you have lovely emotions, just really very thoughtful emotions, just valid emotions, really rich cinnamon emotions. So you can see that this allows you to reuse things multiple times, which is something you might want to do in bots. All right, so this bot is looking pretty great. If you want to explore around some more on artbot.club, you can also unpack things. So this allows you to kind of visualize what's going on here. You also have this section over here, which shows you how your symbols and rules are being parsed. So I can look at origin, but I can also look at maybe here's the complement, and you can see that it's got all these different It shows that I've got my symbol rules here. It shows me that my noun is something that it doesn't know about. So that's just some more options on this Artbot Club site. But now I think we should actually put this bot on Twitter. Why don't we? All right, so I'm going to head over to Twitter in just a moment. Okay, the next thing that we're going to do is to create a Twitter account to host our bot on. So we need a place that our bot can post. I've already made one called Compliment T at Twitter. So Twitter requires you to make a new email account for each bot that you make, which is kind of annoying. I use the plus trick in Gmail to help me out there. Then I create the account. I go to Cheat Bots Done Quick, and I have to allow access, and that'll allow me to post from that account. Okay, we're at the final stage of our bot making process. I've come to Cheat Bots Done Quick here, and I can go back to artbot.club, copy my grammar from there, go over to Cheat Bots Done Quick, and paste it in. You can see now I've got some example tweets down there. I can choose one and tweet that. And hopefully, if I reload, yep, we can see that it's tweeted here. And I can set how often I want it to post a tweet as. So I can have it post every 10 minutes to once a year. And then there's also a neat feature where you can say reply. So if people tweet at this bot, it will say hello and give them a tea and a compliment custom made just for them. So that's it. You've made a Twitter bot in just 10 minutes. So now you can go to artbot.club or Cheat Bots Done Quick and make your own grammar and your own Twitter bot. Good luck.
Hola, welcome to Abstract Sketches with P5.js. My name is Ilitia and I'm a digital artist, creative developer, and designer. Today I'm going to help you get started with the P5.js library as we make an interactive minimal abstract sketch of a GitHub universe. Let's get started. When I make digital art, an idea not always falls from the sky. Oftentimes, browsing for inspiration is always a big help. I wanted us to create a sketch inspired by origami art and stop-motion animation, which is one of my favorite things to do with P5.js. I prepared a small mood board for you so that you can be inspired with me before we get started with our sketch. As you can see, first, we have a universe full of stars, galaxies, and constellations. Then we have an image with origami figures. For the ones who don't know what origami is, it's the art of paper folding, as you can see here. And lastly, we have a stop-motion animation example, where we see objects moving in small increments and being captured one frame at a time. We'll do something similar when we animate our sketch. Let's put our inspiration all together and start sketching. We have a short amount of time for this little tool, so I'm not going to go into depth with the code today. So if you're here and are new to JavaScript or never used it before, don't worry. I'll be sharing the resources of this short tutorial at the end so you can work on your sketch at your own pace. Grab your favorite code editor on your computer or online code editor and let's start setting up our project. Go to p5js.org and click on the link Get Started. Scroll down until you find the downloading a copy of the P5.js library or using a hosted version. If you're working locally, you can go either way. If you're using an online code editor, probably the best way is to use the link of the CDN of the library. I'm using CodePen, which is an online code editor, so I'm going the CDN way, and make sure to link the library within a script tag inside the body tag at the bottom of the body in your HTML. If you are relatively new and don't know about editors or online code editors, you can use one from P5.js. So if you go to the home page, click here on editor, and then you will find this. Let's start coding. I've added some basic CSS for us because that's going to help us so that the canvas that is going to be rendered via P5.js to create our sketch doesn't have any weird margins or paddings overfloating. And also, I've added my favorite color as a fallback. In our JavaScript file, I've commented the plans for our sketch today. We're going to start by defining some global variables. Then we're going to make a custom mold for a space plan because in our GitHub universe, anything is possible. And I wanted us to have some space plans. We're going to have more than one, so that is going to be very useful. Then we're going to draw our GitHub universe with those plans, and we're going to have a moon. Afterwards, we will make our little sketch interactive by adding some stars and galaxies on mouse over, and we will animate such universe and have the possibility to stop and play such animation with a canvas click or mobile touch. Let's first declare our global variables. We're going to need a background color, a shape color, and a stroke color. As you can see, you can declare the colors via hex value or color name or even RGB. Please feel free to use any colors as you like and change this if you want. Now we're going to need as well a shapes as variable. This is going to be useful because once we start drawing our sketch and we want to make the elements a bit smaller or bigger, we can always come up to this variable and resize everything. Another two valuable variables that are going to serve us are these ones that I created and call them shape gap X and shape gap Y. These two variables are going to help us to achieve the origami effect of paper folding. We want to move the primitive shapes that we're going to use to draw our elements a little bit vertically and horizontally. So this is why I in the end, I call them X and Y, thinking of the X and Y axis. The X axis goes horizontally and the Y axis goes vertically. Let's continue by defining our first P5.js function. Before we do that, let's go back to our CSS and change that background color to something different than the one that we have declared in JavaScript so that we know when the canvas is going to kick in from P5.js. Now, the first one is a setup function, which takes a method to create our canvas and is going to have the size of the whole window width and window height. If you wonder where does that comes from, well, that's part of P5 magic. If you open a new tab and you keep the p5js.org website open as you work through this tutorial, click on the reference, and this is going to be the goldmine because in here are all the available variables, methods, and functions from P5.js that let us work fast to create our sketch via the Canvas API. If you don't know what the Canvas API from JavaScript is, I recommend reading the MDN web docs and you can learn about it because the library is based on that. Now, as you can see, I use this method called created canvas, and this one you can find if you scroll down in the part of rendering. Here it is, create canvas, and here they explain this documentation is amazing because whenever you want to do anything, it tells you and it gives you example always of what you can do with it. And the following function that we need right now is the window resize. We are going to add this function just to make sure that once we have our sketch here, we will be able to resize everything and everything is going to be resized automatically for us. We're going to create now our custom mode for our space plans. We're going to do that via JavaScript classes. If you don't know what JavaScript classes are, I recommend visiting the MDN web docs to learn how classes in JavaScript work. Our JavaScript class is going to be called plant. As you can see, our class is broken into three sections. The constructor method is going to allow us to customize each plant by choosing a leaf size, a leaf count, how many leaves do we want that our plant has, and a position on the x-axis. Then we have two functions that I created for us. One, I call it spot because it's going to help us to find a spot for a plant on the ground on the x-axis. And the second function that I created for us is the one that is going to create our plant. There are four functions in our class that we didn't create that come from P5.js. The first one is the translate function. This one is allowing us to move an element in the X and Y axis, and we're not using the third value set because we are not drawing in 3D but in 2D. The other one is the triangle function. This is allowing us to draw a triangle via the Canvas API by entering the parameters of the size of the triangle. I already did the math for us, and as you can see, I drew two triangles because each plant is going to have two leaves and it's going to expand vertically to choose the size of the plant depending on the leaf count. The other two functions from P5.js that I'm using is push and pop, and we're going to need those, and I will explain that later. Let's draw our first plant into our sketch by using the function draw from P5.js. As you can see, it's going crazy because the function draw is iterating several times, and in order to have only one plant, we can add a background color, and then each iteration is not only going to draw the plant, but it's also going to draw the background. And it's going a little bit too fast to my taste, so we're going to go back to the setup and tweak the frame rate. Normally, the default frame rate from P5.js is 30, so we lower it to 4, and now we have this stop motion animation effect I talked about in our mood board. Also, you can already see that our plant has this folding paper effect looking like origami, and it's in here where you can customize. For example, maybe you actually don't want to have any color in your plant, maybe you only want the wireframe, so then there's this function from P5.js called no fill. maybe you want to use another fill color. The default one is white. I also had white, but maybe you had green, and this is where you can change it. For example, if I were to change this to, I don't know, 897, another hex value, here you will see that it's going to change to this color greenish that I was talking about. And now also you can decide if maybe you don't want a stroke, for example, and maybe you want to only have your plants fill in but without stroke. And the stroke color can also be customized. It's the same. The default is black, but if you wanted it to, for example, make it blue, you could totally change the variable, and now we have a different stroke. So just come back to your variables and change and adapt as you wish. And also the stroke weight, you can choose if you want thicker or if you want the default, which is 1. Let's add more space plans into our little universe. I already moved everything to a function expression here in our JavaScript, and it's very easy to create our plans. You can see that you can choose how tall you want your plants to be and how wide the leaves or how thin. I also wanted us to have a moon in our universe, so we do that via the circle function from P5.js, and I created 8 circles to represent the real 8 moon phases via the stop motion animation that we have going on in here. I wanted to show you real quick what push and pop does. Let's comment that out and see what happens with this triangle that we were translating. We see the translation happening differently because the translation is taking place after the other translation that we have previously done. Push function saves the current drawing style settings and transformation, while pop restarts the setting. So I wanted to have this translation on the second triangle independent from the other translation. This is the reason why I'm using it often when I don't want the translation to be dependent of the previous one. Lastly, let's add some stars and galaxies on mouse over to our sketch. Let's make it interactive with the function mouse move from P5.js. I decided that our stars or galaxies shouldn't have a stroke, and I created them with a circle. I decided that each circle should be drawn by following the mouse in the X and Y axis. And as you can see, the stars are randomly different sizes. I'm using the random function from P5.js, which takes one value, which is the choices, or you can set up a minimum and maximum value. As you probably already noticed, and I forgot to tell you, is that we were using already the random function on the moon, and also when we created our plan, as we were translating the x-axis randomly from one value to another in order to create our stop motion animation effect. We implemented a way to draw our stars and galaxies on mouse over, but we see them disappearing every time we move the mouse. This happens because the function draw from P5.js resets the function mouse move every time it's drawing again or sketch. We need to find a way to stop the drawing function from P5.js to continue so that we can draw our actual stars and galaxies. In order to do that, we can use the mouse press and touch start functions from P5.js. We will use both because the touch start function is going to allow us to interact with the sketch in touch devices. I created a function expression called toggle draw for us so that we can use it in the mouse press and the touch start functions from P5.js. This is going to allow us to stop our animation and draw our stars, or reset the stars that we draw and loop back to our animation. We're using 2 functions from P5.js to achieve that. One is called no loop, which is actually stopping the drawing function from P5.js. And when we want to redraw, we call the loop function from P5.js. Now let me show you the final sketch where I drew my stars and abstract galaxy going on in here. As you can see, you can go crazy and add as many stars as you want. Maybe you want to have more plants too at the bottom, have a full bush, or maybe you want actually less plants, like only 2. Maybe you want to have 2 or 3 moon phases happening in your little GitHub universe. Really, anything is possible and you can do as you want. Feel free to share your work with us if you want on Twitter and Instagram by using the hashtag GitHub Universe, and you can tag me, I'm Ilitia_net. I'll be happy to see what you came up with in this little tutorial. I'm also sharing with you the link to the resources of this tutorial, which is a GitHub repository where you will find everything that we did today so that you can practice after this tutorial at your own pace and create your own abstract sketches. Thanks for being here, and I hope that you learned something new today.
Hello, everybody. It's lovely to be here. My name's Ruth, and I'm a creative coder based in the UK. I use web technology as my primary environment, which means most specifically, I usually work in JavaScript as my primary language. I'm here today to talk to you about programming audio with JavaScript, and for that, I'm going to use the Web Audio API. This is one of many web APIs which come out of the box within a browser environment. So if you build websites or web apps with HTML, CSS, and JavaScript, there's a lot of APIs at your disposal. Things like geolocation, device sensor control, browsing resource management, and media APIs. You can find out more on the MDN Docs web API page. So back to audio. Let's address one thing very quickly, and that's audio on the web. People are not keen on that. However, with the rise of games, XR experiences, and art, audio plays a huge role. So having a good low-level API to create and manage audio is very worthwhile. There's a lot of functionality within the Web Audio API. I have 10 minutes of your time, so I'm going to give you a quick demonstration. One thing to understand about the API is it works around the concept of nodes. Each bit of functionality is a node. There are input nodes, ways of loading or creating sounds. There are modification nodes. These make up quite a bit of what you can do. You can adjust volume, apply filters, add echo or spatialization. You can even analyze the sound. Then there are output nodes. By default, the sound is output to the speakers, which by and large is how you'll work. But you can also output to buffers and files. Here I've got a web page with a button on it. Here is the HTML. I've got a button. I've added some styles to it with the CSS. But what I'm going to show you is how to make a sound when we press that button. So we're really interested in the JavaScript here. I've grabbed a reference for the button and added a listener for if the button is clicked. The first thing that we need to do before anything else is create a context. This gives us all the functionality of the Audio API. The Audio API only allows sound on user gesture, i.e. the user must interact with the page to play noises. This means you can't autoplay them when you load a website or app, which is a big pain point with audio anyway. So in our case, this means we can start it once the button is clicked. The way we do that is checking the state of the audio context and resuming it if it has been stopped. I've already created a name for our function. We just need to call it within that click code. The first thing we need to do is create an input node. Now, there are a few different types of input nodes with the Web Audio API. You can load a file. You can get the audio from the HTML if you've used an audio or video element. You can create a buffer and fill it with your own data to play. This method is good for things like white noise. You can fill a buffer with random numbers. I'm going to create an oscillator as my input node, which plays a clean sound wave, like a sine wave, a square wave, a triangle wave, or a sawtooth wave. The difference between these types of waves is the shape of the actual wave, and we tend to have these shapes by default with electronic oscillators, as they are easy to generate electronically. So let's create an oscillator using the aptly named createOscillator function. I'm going to set the wave type to triangle. I do this with the type property. We want to start and stop the oscillator, for which the oscillator gives us methods. So we do oscillator start and oscillator stop. We'll add a parameter for when we want to stop the oscillator. It takes in the time it wants to stop. In our case, I'm going to be 1 second from when we start it. To do this, I'm going to use the audio context.currentTime property, which returns the time in seconds since the audio context was instantiated. In this case, I want the oscillator to stop 1 second after this code, which means I just add 1 to this property. One important step, which is easily forgotten, is connecting our nodes together. This is called connecting the audio graph. We need to connect our input node to our output node. By default, the destination property is the speakers. So we need to do nothing else here. Now we should be able to play our oscillator by clicking on the button. Great. Let's add a couple more things to make that sound a little bit more interesting. Let's change the frequency of the oscillator. The frequency is the pitch, so whether it sounds low or high. By default, it's 440, but let's make it a little bit lower. I also want to make the frequency higher as it gets played, so over the seconds that we're actually playing this oscillator. We can do this with a method called exponential ramp to value at time. All that really does, is a bit of a mouthful, is it moves the value which you're specifying over a specific amount of time, but as a nice curve rather than just linearly. Now that sounds a bit, how should I put this, forced. Let's also drop the volume of the sound too, so it tails off as we play it. I'm going to do this by creating a modification node for volume. It's the gain node with the Web Audio API. So let's create our gain node. And not forget to connect it to our graph. We can chain our nodes with the connect method. So here I can say my oscillator is connected to my gain, which is then connected to the destination, to the output. On my gain node, I'm going to use the same exponential ramp to value at time. It's available on most audio node parameters within the Web Audio API. So we're shifting that value in a nice curve over time. I want the value to be almost naught and the value to be just under a second. So it's just tailing off nicely. Let's see how that sounds. Pretty good. It's worth noting here that there are quite a few different modification nodes that you can play with. There's a wave shaper node, which changes the shape of the wave. There's a convolver node, which gives you echo effects. There's filters, which can cap or allow specific frequencies through. There's spatialization. There's plenty to play with, but this is just a very quick introduction because I'm nearly out of time. You can check out more about web audio on MDN Docs, where I've written some introductory and advanced tutorials to help you discover more. Thank you very much for watching. I've been Ruth. You can find me on Twitter and GitHub as Rumira. Thank you very much for having me.
Welcome to this 10-minute run-through of ModV. What is ModV? Well, ModV is a free and open source piece of software which allows you to pipe in audio and generate audio reactive visuals, which are great for live shows such as AV shows and gigs, anything with a projection behind it which needs to be synced to audio, really. ModV is built on web technologies, and I've been working on it for around 6 years now. We have two main contributors, who are myself and Tim Pietruski. Both Tim and myself have used ModV in shows all over the world, with kind of live use spanning from around 4 to 6 years, respectively. So, let's get into it. Down here is the gallery. It contains modules. Modules are visual generators. There are 3 types, which are 2D, interactive shader format, and WebGL shader. To set your input of audio, you click Input Device Config, and we'll set it to my microphone. So now, 1, 2, 1, 2, we are using my microphone as the audio input. We can drag a module into a group and click Enable. You'll see in the preview window that the module is drawing over itself each frame. We can stop this behavior by unchecking inherit and checking clearing. This will clear the canvas at every frame. Modules can be mixed and matched as you like. So we can drag and drop and just click enable, and now we have another module drawing to the screen. Each module has a set of controls, which can be modified in the module inspector in the top right. So let's get the object distance a little up, and then we'll up the stroke weight, a little bit of circle spacing, and now it looks kind of different. Each module has its own set of controls, which you can see by clicking on the module, and they'll appear in the module inspector in the top right. If we select a module and hit backspace, we can delete the module from the group. So let's drag and drop scale, and we'll put it before concentrics, click enable, and you'll see that nothing much happens yet. But if we uncheck clearing, now we have this infinite drawing to the screen, and every time the frame draws, it will draw the previous frame a little bigger. So you get this tunnel effect, which is quite nice. We can extend this even further by finding a block color, dragging and dropping this, clicking enable, and we'll turn the alpha up slightly, and now every frame that's drawn to the screen will be drawn slightly darker. So we get this nice fade to black. You'll notice that in the input configuration panel, each property that we click can be configured. So let's go to scale and select scale. And in the audio dropdown, we will select energy. Now, this looks like it maybe hasn't done much, but if we slightly restrict the maximum value of energy, we can see now that every time I speak, and let's just turn down the circle spacing slightly so this is a little more obvious, that the scale is being affected by how much my voice is making sounds. Sorry. But yeah, so we've now assigned an audio feature of the incoming audio to a module's property. Meda is the audio analysis library that we use underneath ModV. It allows us to select certain features of incoming audio rather than just using the standard FFT values, which I found produces a much more punchier result than just sticking to standard FFT values. We're looking to bring FFT into ModV at some point, but for now we only support Meda's audio features, which work surprisingly well. You can create new groups by clicking New Group, rearrange groups, and even drag modules between groups, and drag them back. Blend modes can also be set for modules and groups, just like you would in Photoshop. And let's look at that here, and we'll click Difference, and now we can see there's some funky stuff going on over here. Let's maybe try hard light instead, and now we have this hard light looking kind of blending going on a little bit. Let's check out what's going on in the output window. So this would sit on your secondary screen or projector. You can resize the canvas just by resizing the window and double click to go full screen. Hello, 1, 2, 1, 2, 1, 2, and double click to get out of full screen. Once you've got an output that you like, you can save this into a preset in the file menu, and you can open a saved preset also by the file menu. You could share presets with friends if you'd like. Just make sure that they have the modules that you're using. Along with the built-in modules, ModV allows loading of your own modules too. Let's quickly see a 2D modules code and how they are built. A module in ModV is a JavaScript file which exports one object. We need to give the module some metadata, so we tell it what kind of module type it is. In this case, it's 2D, and we can give it a name. So let's remove just those two for now, and we'll find circle in our gallery. And this is being loaded from the file system. So we click enable, and there's nothing going on here. So let's uncomment props. And this is kind of like your view or React properties. So we have one property called size, one property called color, and we give it some details about the properties here. So it's an integer, it's default 20, minimum should be 0, maximum should be 100, and it should always be 0 or above. That's ABS, absolute. And the color is a type of color. So we'll save that, switch back to ModV, and we'll see that we have size and color properties enabled, but it's still not drawing anything to the screen. So let's look at the draw function. This draw function is similar to what you'd find in P5.js, processing, or open frameworks. So let's uncomment that, save it, and look back at ModV. We have a red circle drawn in roughly the center of the screen. So what can we do with this red circle? Well, let's change the color. Nice. So as we saw, we can't go past 0 and we cannot go above 100. But we can still assign these audio features to these properties. So this is a little quieter. So we're just going to turn up the maximum on our audio input. And there we go. We have a bouncing green circle. Super interesting. But there's more that you can do with ModV than just bouncing green circles. So to show off ModV, why don't we have a little jam? I'll be using music written by myself, and all of the modules used to create the visuals will be default modules found in ModV. Let's take a look. ModV is a long-term passion project of mine, and we're always looking to improve and add new features. If you'd like to have a go, visit modv.vsync.gl and see the Getting Started guide. We sometimes run workshops on ModV, so if you'd like to see a more in-depth run-through of ModV and have a go for yourself with a little support on the side, then check out our Twitter page as we have one coming up. If you notice a bug or you have an idea, PRs and suggestions are more than welcome. I hope you'll check out ModV and even use it at a live show. I've been Sam Ray. Thank you.
Hey everyone, I'm Moritz Simon Geist and I welcome you to my talk making futuristic music with robots. I'm super happy to be here at the GitHub Universe conference. Actually, I'm not here, I'm more in the internet, kind of here. I'm in Dresden, Germany in my workshop, and this is a good thing because I'm surrounded by all my robots. I brought several robotic systems here, and in this talk I'm gonna be talking a little bit about how to make music with robots, what that actually means, because I'm a robotic musician, how to create, build, and play with them, and then I will also talk a little bit about how to perform with them, and I'm also giving a small performance. So let's get started. I'm a musician, robotics engineer, and hacker, so more of a hardware hacker type. And a lot of times, often people ask me, hey Moritz, what are you actually doing as a robotic musician? What does that mean? And so I tell them 30% of the time I'm making music, 30% I'm building robots, 30% of the time I'm thinking about the future, and the other 30% I'm doing business, and that is combined 120% because I sleep less, I don't know. Okay, anyway, I'm here in the middle. You see me in the gray part. When you mix other colors, it's gray. Wonderful, yeah. So basically, I started off as a bass player in a punk band. I did music for most of the time of my life, also playing piano and clarinet. And then I thought, okay, making music is actually not such a good way to earn money, so I studied something scientific. I studied electronical engineering here in Dresden, and I went on the route for making really scientific things in semiconductor science. But I soon realized that to work in an office and like have all these like research things around, that's actually not the thing I really wanted to do with my life. And so I thought, okay, I'm going to combine these two things. I'm going to combine the music and the scientific thing, and I started building music robots. I soon changed my student apartment into a big mess, and I put a lot of cables and things around there. And out of this mess came my first installation, which is the MR808. Maybe some of you have seen it. It's a huge installation, 6 by 4 meter. The lamp here is for scale. And no, not 6 by 4 meter. That's too big. Like 2 by 3 meter. That's the size. And it's basically a replica of the 808. The 808 is, of course, the TR-808, one of the most iconic drum computers in the universe, brought to market in 1981 by a Japanese company. And I thought, okay, I'm going to replicate most of the modules there, and the idea was to have no electronics involved and to replicate all the sounds of this electronic drum synthesizer with actual drums and with small mechanics and small motors. So this, for example, here is the drum module with darbukas, and then we also have like a clap module, and you can definitely check it out in the internet if you want to see a video. It was viral in 2012 when the internet was still young and the installation was also still young because it's from 2012. Yeah, the goals for the 808, actually I didn't have a plan, but like it appeared that the goals for the 808 would be to have a sound creation which is much more visual appealing. That means that you have like all these small things and they basically move, and you can really touch them and go there and just like do stuff. And this is something that you cannot do when you have like a computer, or which was really lacking. I started making electronic music a long time before I started building robots, but what was always lacking for me was like this touch of physicality, that you cannot actually touch something and it changes. So definitely another goal would be to have no more sound creation inside the computer, and also like this extension of creativity, because it's a very limited scope of sound creation. Actually, you have only the sounds that come out of this instruments. So maybe enough for the forwards. I would say now I'm starting my live set, and I will switch to my software of choice, which is Ableton Live. I don't know if you know the Fact magazine. They do something called a 10-minute track, track in 10 minutes, and I will do the same here. So maybe let's start off with the bass. When I play live, my first question is always like, what's the most important thing in electronic music? Bass drum! What's the most important thing in electronic music? Bass? Definitely. So we're going to start with bass. There's only one person here, Paul, which is cool. But of course it doesn't, I cannot play live this year, but it's fine. Okay, let's start with bass drum. The bass drum here is an old vinyl player, which I converted so that it's basically not moving anymore, but it's only hitting on the on this plate, on the cardboard. It's amplified with a little EQ, and then you basically have a wonderful bass drum out of like a small mechanical motor. Okay? The next thing is like a hard drive. Because I figured out a hard drive is a wonderful thing for making sounds. Apart from storing data on it, you can also cut them apart, then you can basically not access the data anymore, but it's really good for making sounds. So I have a few of them here. Okay, that sounds pretty nice. So I'm also in for guitar sounds. Let's see how this works. I'm controlling everything live here in Ableton. If I press one of these little blocks here, then there's a MIDI note triggered. MIDI is a format for controlling MIDI synthesizers. Probably all of you know it. And this is basically converted into electrical signals, and they are then transferred to the small instruments. So, okay, let's get started. The guitar. Nice. Okay. So, what we have here is a normal guitar, which I converted with like 2 robotic arms, or like arms with motors on it. They are then basically triggered by these notes. So I can also put a lot of notes, for example, like this. But that doesn't sound good. So I remove it. Let's get it. Let's get to it. Yes. Okay. Okay, what we also need is hi-hat, okay? We have like a standard hi-hat because I figured out that this is actually pretty cool. And I will also do like a small rhythm here. Okay, pretty nice. Okay, so the thing with all these music robots, it's pretty easy to do something which is percussive, but it's very hard to do something which has to do with melodies, because with melodies you always need like a bigger instrument where all the tones are basically sounding kind of similar. So for live shows like this one, I like to add some synthetic sounds, which is kind of a fake robotic sound, and I'm just doing it because I like bass so much that I basically just do it. Okay? I'm choosing this one. So this is the bass sound. All right, let's try it. Oh yeah, pretty nice. Okay, that's already pretty cool. There's another instrument which I want to introduce. This is my robotic kalimba. This is something that I developed in the last years, and it basically refers to an instrument which is like a normal African kalimba, like this one. But here you basically have all the metal parts as small robotic devices, so that I can trigger them from far away with my computer. And I'm just setting a nice rhythm here, maybe something like this. Okay, let's see how this sounds. Okay, pretty nice. Oh yeah, pretty nice, pretty nice. Okay, cool. Okay, that's what was missing. Let's see. Okay, so one of my favorite instruments is this instrument. Okay, it's basically a shell which somebody gave me as a present, and it has the wonderful sound ever. Because what I also like is to find hidden properties in objects, and this one wasn't meant to make a sound, but I can show you how it does. Really nice. Super nice. It's actually dropping. No problem. problem. My computer just crashed. But this is kind of live, I guess. Cool. This is still running. Some of my robots run without power, which is great. Let's see. Okay, that was my contribution to this year's pandemic version of GitHub Universe, and I hope that 30 minutes are fit. I don't know what time is it now. So normally you would find this kind of music in a club or a media arts festival or such. And since there's not so much possibility right now to do this, you can find me in the internet at various places. And I hope you enjoyed my performance. And if you have further questions concerning the setup, I didn't go into detail about the programming of the robots, for example, because that's a little bit hard to do here with this particular setup. And so if you have further questions, you can just post them or write me an email or come over to Dresden, Germany. We have a wonderful workshop. And let me just finish with this. Thank you.
I am Reeps1. I'm also known as Reeps100 sometimes, and I'm here today to showcase a new piece of my work. It's a performance, an interaction that pushes me further. It makes me uncomfortable. I call that discomfort and that testing an intelligent interruption. Before music, I actually came from tournament chess, and my opponents were my greatest collaborators. That idea that to have ownership over that discomfort, they're the ones that pushed me further. So sometimes it's not about harmony, it's about how our expertise and our skills can be forced into new corners and new places. Today, I'm going to be interacting with a number of synthetic voices. Over the last 4 or 5 years, I've done a number of projects and worked with a number of tools that allow me to create audio. And whether that's artificial intelligence and machine learning or just interesting processing, this amazing bank of sounds normally sits static in my hard drive, where actually I've collaborated with Artbot to create a max patch. This max patch allows me to interact with these different audios. It listens to me, and I'm going to have 4 to 5 chess matches with these different collected audio pieces. I have no control over what they do. It's a chaotic process, but the idea is I will do unexpected things, and it forces me to write and compose in a new way. So for example, if I was to make what you have there is a reply. So the reply you just heard was from audio created with Artbot using sample RNN, a generative version of myself, hours and hours and hours of performance used as a data set to create hundreds of hours of patterns and phrases that I'd never done before. But now I can speak with that audio. So this gauntlet that I'm about to walk through, these number of interactions, are all about how we can question expertise and we can question our human fundamentals to become something more academically, artistically, and most importantly, as an opportunity to push the very idea of what it means to be an expert. I hope you enjoy. Ready? Okay, ready?
Hello, everybody. It's the end of day one of GitHub Universe 2020. And because you've stuck around, you're in for a treat. And if you missed a bunch of today, well then, I'm really going to knock your socks off. Go grab a beverage of your choice, kick back. This is the GitHub Universe Highlight Show. Hello, everybody, and welcome to the GitHub Universe Highlight Show. I'll be your host, Kyle Daigle. Over the next 15 minutes, I'll be sharing some of the highlights from today, including our huge keynote and all of its announcements, highlights from the 17 talks that you definitely can't miss, our absolutely killer play track, and of course, I'll have you completely ready to go for tomorrow's session of GitHub Universe, which kicks off at 9 a.m. Pacific. I know, it's a little fast to be worrying about tomorrow, but I don't want you to miss out on any of our totally virtual GitHub Universe this year. But before we worry about what's coming, let's sink our teeth into what's already happened. Kicking off today, Nat, Neha, Ryan, Diana, and Brian gave us a jam-packed overview of what it's like to use GitHub these days. We've made quite a few changes in the past few years that make GitHub more useful day to day, easier to get your daily work done, and hopefully a little bit more enjoyable too. Kicking off the keynote, we announced that GitHub Discussions is now available in public beta to help you and your communities collaborate together. Should be clipped too. Can we kill this?
And I catch up with my favorite communities. GitHub Discussions makes this so easy. We announced it a few months ago as a great place for Q&A and open-ended conversations, and today we're announcing that every open source community can try GitHub Discussions with our new public beta. Just head to your repo settings and turn it on right now. We've learned a ton from the communities that have already been using discussions, and we've added some great new features like customizable categories and native support in our mobile apps. It's awesome.
Sorry about that. That was a little bit of a bigger view in the keynote, showing you how mobile and discussions are now available for you in public beta. They're a great complement to GitHub Issues for planning your tracking in your work. Try out the features that Nat mentioned, like customizable categories and native support within our mobile apps. GitHub's upcoming dependency review tool is going to give you a clear view of the security vulnerabilities you're bringing in with all of those dependencies. And what's a better way to support the creators and maintainers of those open source dependencies than by supporting them via GitHub sponsors? GitHub Sponsors has paid millions of dollars directly to developers for their open source work. But today, we're going full business and upping the ante. GitHub Sponsors for companies will help organizations join in supporting the open source ecosystem and helping keeping it strong for many years to come. And a special thank you to companies like AWS, American Express, Daimler, Indeed, New Relic, Notion, Stripe, Substack, and many more for joining us in this launch to support our open source community. Now, if you've ever wanted to code while you're out and about, or maybe on that underpowered computer when you're visiting a family member, we have a solution for you too. No more with messy onboarding. You get a complete developer environment with just a few clicks with GitHub Codespaces.
GitHub Codespaces gives me a complete dev environment right in my browser, even on an iPad. It's like an infinite dev box configured in code, just how you need it.
And alongside GitHub's mobile app, available for iOS and Android, you have a complete developer environment and the best developer tools in the world on your phone or tablet, just a couple of taps away. And on top of all these features, we have a bunch of new workflow improvements that are going to speed up your time to production while also making sure you have all the checks and balances your process needs.
Now, when your branch protection rules are met, your change is approved, and your checks are green, GitHub can automatically merge your pull request for you. Just tell GitHub how you want to merge with a commit, rebase, or squash, and we'll make it happen.
Also, the GitHub Action to require manual approvals for action workflows. You can set protection rules and give each environment dedicated secrets. That means you can make shipping painless while also making sure authorized team members can deploy to production.
These new improvements are so good. At GitHub, we're able to use auto merge to get pull requests into their action workflows faster than ever for some projects. And for parts of the app that need a little bit more review, manual approvals allow us to check our test deployments before letting our continuous deployment workflows take over for us. GitHub Actions is now a full-featured CI and CD platform ready for you to use. I can't wait to get these features into your hands because sometimes it's the little things that make the biggest difference. And finally, if you use GitHub on premises, we're bringing all these amazing features to GitHub Enterprise Server with our new release, GitHub Enterprise Server 3.0, including GitHub Actions, packages, code scanning, and more. We'll catch up with Maya's talk covering all of these new features in just a few minutes. You can learn more about Enterprise at enterprise.github.com. Oh, and one more thing. Let's shine a huge light on something that's a little dark, GitHub Dark Mode.
Whoa.
Nat!
What was that?
Nat! Are you okay?
Is it real? It's awesome.
I gotta up my slipper game after watching that. I know you've been asking, begging, pleading for this feature for a while, and we're happy to announce that it's here. GitHub Dark Mode is available now, today, right this minute. Either use your system settings or the settings within GitHub to quickly enjoy the dark, dark bliss of a much darker coding experience. I promise as soon as I'm out from behind all these lights, I'll be turning on dark mode too. And you all loved the announcements, that much is clear. Let's take a dive into your hot takes on social media and see what you all thought about the keynote. I'd love for you to share what you're loving or finding exciting about GitHub Universe. All you need to do is tag it with the hashtag GitHub Universe, and your tweets and Instagrams might show up in our highlight show as well. All right, let's take a look at what you thought. First of all, meet Bruno, a cat programmer who seems to really be enjoying, or maybe is utterly confused by the play track performance, I'm not sure. I love seeing where you all were watching from home today, and Bruno, please stick around for day 2. Moving on, Brady's family was a little confused by his big excitement for GitHub Dark Mode. Listen, I think I could hear all of you from my house, and this room is pretty soundproofed. I assume you explained to them the utter importance of Dark Mode, Brady. And finally, Sunny caught a line from Nat in the keynote about how GitHub sponsors can let open source developers work for the internet. We already have many developers on GitHub sponsors making 6 figures full time, which is awesome. And maybe not quite a cat and mouse duo, but now we have Boris watching GitHub Universe from Miles's house. And I think he's taken a liking to Martin and Dana. Boris should meet Bruno and then Mona. Feels like we have a whole programming cartoon on our hands. Share what you're thinking. What was your favorite part of Universe? Use the GitHub Universe hashtag. I'd love to feature you in the show. Moving on, we also had 17 talks today, covering the gamut of topics, from more info on GitHub Codespaces, an easy and powerful way to do development from a web browser, to how you can do secure development, whether you're working on github.com or GitHub Enterprise. I wanted to share a few of my favorite moments from the talks, but you can see all the talks on replay by going to githubuniverse.com. As you saw in the keynote, Codespaces is the best way to both edit and run your code with the power of VS Code right inside your browser. Earlier today, Bailey, Matthew, and Allison shared how you can start writing new code, run your tests, run your actual application, and then deploy to production from almost any browser.
In line with the specified license, maintenance risks if a dependency is no longer supported and you don't have a viable alternative, and other risks as well. So to make the dependencies that you pull in...
Personally, I'm looking forward to not fumbling around when I set up a new code base. And I'm really excited to be able to use my laptop or an iPad to develop while linked to a VM in the cloud. Be sure to check out both the replays from both the Codespaces talks to learn more, or just go and sign up today. You can find the link at github.co/codespaces, or just head on over to github.com. Okay. Now, we have a new feature that is very important related to security. Now, what is one thing that basically every new feature has? It's code. And what does almost every piece of code eventually have? Security vulnerabilities. During today's talks, a bunch of our speakers shared how GitHub, their companies, and many open source communities are trying to make it easier to write secure code much, much earlier in the process. Here's Maya sharing how GitHub can help make it even easier.
That means that instead of having to identify, examine, triage the vulnerabilities and dependencies yourself, with these features, with Dependency Graph, Dependabot alerts, and Dependabot security updates enabled, managing a new vulnerability is as simple as merging PRs from Dependabot.
If we haven't convinced you yet, security is more than just something you need to worry about. It's something that you need to consider from the very beginning of your development project. And Keith from Thermo Fisher Scientific thinks you need to treat security as an actual feature.
This is kind of like the faucet that you go to or the sink that you may go to. And when you turn that left knob, you expect the water to be hot. That's universally true. You didn't have to ask anyone for it, and you didn't have to tell the plumber to install it that way. It's just the way that that operates. And so in a lot of ways, that's the way that people think of security today. Is
Now, Maya William shared how we can keep vulnerabilities out of our code, and Keith talked about the importance of security as a feature. What happens when, you leak a production secret into the code base? Look, don't judge me. You've done it. I've definitely done it. But luckily for us, Sasha shares how GitHub code scanning protects us from getting into this big mess at all.
Well, if you as a user check in your code and that code actually contains a secret, so we actually run different regular expressions from known secret scanning partners to identify if something you committed actually matches one of these secrets.
You're not mining any Bitcoin on my dime, I'll tell you that. All the many tokens I've pushed up have already been revoked by GitHub and its partners. Thanks to computers being both wonderful and completely and utterly terrible, Spencer from the Metasploit project spoke about how to write an exploit module and then check it against targets for vulnerabilities. Here's Spencer describing why he finds working on Metasploit so interesting.
I talked a lot about like writing the exploits, and that's really where it's at. I always find that incredibly exciting because you're tinkering with things, and it's oftentimes a puzzle where you're trying to create content to leverage functionality or a feature or a bug in a way that it wasn't originally intended to be leveraged. So
Special thank you to Spencer and the Metasploit team for building such a powerful tool. GitHub's been working hard to bring you more features that keep your code secure before it gets into production. And during their talks today, Boz, Xavier, and Justin shared how we're helping developers use GitHub Advanced Security. And Boz and Xavier shared how the community is using CodeQL to find more novel vulnerabilities than ever before. To learn more about CodeQL, head on over to securitylab.github.com and be sure to check out the full talks from today and dive into how you can use CodeQL yourself to find all the vulnerabilities that you can think of in your own code. And of course, check out github.com/security to learn more about all the ways GitHub can help you with secure development. And finally, if you're a GitHub Enterprise customer, there are amazing features, workflow improvements, and security automation coming to you in our next release. Here's one of the many demos from this talk showing off the new private pages feature to make inner sourcing even easier.
This is a company wiki built on private pages. Private pages, again, is another new feature which is in beta now and which is going to launch for everybody before the end of the year. And what it means is that you can create pages, just as you know and love them with GitHub, which are only accessible by people in your enterprise.
There's more where that came from, though. Just to name a few, we've got GitHub Actions on premises, automated code and secret scanning alerts, conditional access policies to better lock down your environment, and extended branch protection rules that are environment aware. There's too much for me to cover here. You should check out Maya's whole talk as a replay. And best of all, these features will all be available to you in a release candidate starting next week. In our third track of sessions, the university track had sessions today aimed at student developers, like a talk from Emoju Miller, technical advisor to the CEO, about the myth of innate technical ability, and a talk from Mike Swift, CEO and co-founder of Major League Hacking, about how everything you think you know about tech internships is wrong. If you're a student and interested in diving in yourself, head on over to the university track to prep for day 2. And phew, if 3 tracks of talks and sessions weren't enough for you, did you take a look at the play track? The play track has some of the coolest, most artistic uses of technology that we could find, and we are so excited to bring you more this year. And check this out. This is Sarah Davis, who also goes by DJ Dave on Spotify. Go check that out. She's live coding this amazing track that helped kick off GitHub Universe. The GitHub team was so loving every second of this performance, and so were you on Twitter. Be sure to check out her performance and all of the amazing performances on the play track tomorrow. I promise you, they are worth a watch and listen. All right, we've covered the keynote, the talks, the 4 tracks, and all the performances from today. How about we take a look at what's coming tomorrow? To help us out with that, I've invited Liz Sailing, Director of Software Engineering, to tell us a little bit about what she'll be helping to present tomorrow. Hey, Liz.
Hey, Kyle.
Thank you so much for joining me after such a busy day. So I know we worked together a bit on paying down some of GitHub's technical debt over this summer alongside so much of GitHub engineering. Can you give us a little sneak peek of what you'll be talking about tomorrow?
Absolutely. I am so excited to share with you how we coordinated the efforts of dozens of engineering teams and hundreds of engineers to pay down technical debt here at GitHub, that we were able to significantly invest in the state of our software and our systems and making it faster and easier to build and ship GitHub. And even I was in the middle of it, right, while it happened. And I love seeing what we put in place to keep improving on this new and improved state. So if you're interested in how we do DevOps here and the metrics that we watch to know how we're doing. And frankly, if you just want to hear from a couple of the amazing engineering leaders that I get to work with, come hang out with us tomorrow as we talk about how we came together to tackle our technical debt.
Well, Liz, there is snow on the ground here in Connecticut, but in your honor, I put on my nerdiest Hawaiian shirt. I hope you're in a much warmer situation than I am today.
I am. It's a balmy, 79 degrees here in Kona. Maybe that'll be my talk for next year at Universe, is how we can all work from amazing paradisical locations.
See, now you're talking. Thank you so much, Liz.
You bet.
And you can watch Liz, Keith, and KK's talk about reducing GitHub's technical debt tomorrow on the developer track at 10:30 a.m. Pacific. Along with Liz's talk, there are a bunch of great talks for you to check out tomorrow at 9:30 a.m. Pacific. You can learn more about visual tests on every pull request from Angie Jones at 10 a.m. Pacific. Join GitHub's own Brian Douglas, who will help you get traction with GitHub Actions. And finally, check out the newest continuous deployment features that you saw in today's keynote at 11:45 a.m. Pacific with Chris Patterson. Thank you so much for joining me for today's GitHub Universe Highlight Show. I'd love to hear your highlight from today. Use the hashtag GitHub Universe and feel free to mention me, K. Daigle, and you might end up in tomorrow's show. GitHub Universe will also kick off a rebroadcast with live hosts at 9:30 a.m. India Standard Time. So if you're in the Asia Pacific region, be sure to check that out. Enjoy the rest of your evening, day, or morning. I'll see you back here tomorrow at 1:15 p.m. Pacific. A special thank you to the team that helped put this show together, and I'll see you tomorrow.